What is going on, guys? Welcome to C++ for absolute beginners, where we're gonna fit the entire C++ coding into this one video. So we're gonna start our C++. If you guys don't know about the C++, don't worry. We're gonna show you everything's whatever you guys need from the beginners, and we're gonna go all the way to the advanced levels. So at the end of this video, you guys are gonna be very confident and very competent in C++. So you guys gonna have very good knowledge and gonna have very good commands of C++. So without further ado, we're gonna start our C++ for absolute beginners. First thing first, what is C++? So C++ is a programming language, just like any other language, say for example Java, our PHP, our C Sharp, if you guys heard that. But if you don't know about these other languages, don't worry, we're gonna make videos about these ones as well. So standardized means it has a standard. General purpose, it means it has you can use it for any purpose you guys like, whether it's if you guys want to build an operating system, or whether you guys want to say make a jet engine, or programming, or say for example if you guys want to build this program, use C++ for NASA or any other purpose. It's object oriented, means we have a classes, and everything revolves around a class and methods, and it's compiled language. It means guys need a compiler, which I'm going to show you guys in the next video when we install the say IDE, and then we're going to need a compiler. So it means it's a compiled language. So every C++ compiler is accompanied by a set of usual functions and containers called the C++ standard library. Bjarne Sorstrup created C++ as an extension of to a C programming language. Still, C++ evolved to be a completely different programming language. C++ is similar to C, but are very different programming language. And I'm going to repeat again, C and C++ are two different languages. Say C++ started as C with classes, but it is now a completely different language. So C++ is not C. Keep in mind, C++ is not C. C++ is not C with classes. It is just a C++, and there is no such thing as a C, or if you guys say there is no such thing as a C/C or C++ programming language. C is a procedural language, and C++ is object-oriented programming language. As I said before, here on the top, that C++ is object-oriented language. It's not a procedural, because C is a procedural language. So if you guys see in this one, there is no such thing as a C. You guys can't say that, because if you guys want to learn C, it's a procedural language. So you guys can say easily that C is a procedural language, and C++ is object-oriented language, which everything revolves around object, as I said before. And how we're going to define the objects, because objects are instances of the classes. And don't worry if you guys don't know about this, or if you guys if your head is spinning now, so don't worry about this one's term. So when we get to the classes and functions, then you guys going to be easily understand this. C++ is widely used for systems programming as well as application programming. So C++ is a language that allows us to get down to the metal, where we can perform low-level routines if needed, or soar high using abstraction mechanisms such as templates and classes. So C++, the source file, when we write that one, you guys need to put a .cpp. Say for example, if you're programming, if you're programming your program's called ABC, you guys need to put abc.cpp. That's what the computer understands. So when the computer comes in and encounters this one, then the computer knows that this is a C++ file, the CPP, C++ file, and the header files have .h extension. So what is the header file? So for example, if you guys create this the main application, this is the CPP. If you guys want to create another file that helps this file, say for example like a helper, you guys need to put a H, and you guys need to put it including the CPP. So the compiler comes in and looks for this CPP file, not for this header, because this header is just you guys can put on the head of this one. Say for example, you guys can think of you are building a house. This is the main house, the main entrance, and this is just for the side of the house. So this house is just a room. you guys can create as many rooms as you guys like. Say for example the main entrance of the house is this one .cpp, say for example number 1 or number 10, number 100 in your street, and this is just a room, our you can say in the back room, our garage or something like that. It's because this is that header file, this you guys can connect to this cpp file, but when the compiler comes in and looks, it looks for the cpp file. So if you put some file, say for example bb or cc or xyz example.h, and if you guys including this one, say .cpp, and if the compiler can't find this header file, then you guys gonna be in trouble. Then your program is going to crash, because when you guys going to put this .h into cpp extension into your source code here in your main file, then you guys need to put this, provide some sort of file. Then you guys need to have this .h, say abc.h in your system. If you don't, then you guys have a trouble, because if you put this .h here in cpp, then the compiler looks for this h. It's gonna look for the, you can't just ignore that. You guys just merely put that one inside your file, but it doesn't exist. You know, this .h file has to be inside the system, so the compiler can go and check inside this one. Say for example, if you have a house, if you put a door there, and if you try to open the door and there is no room there, so you guys are going to be extremely frustrated and angry. Same as compiler, because C++ is a compiled language. So now we're going to discuss about the compiler. There are a lot of compilers for C++. Say the first one is G++. Is a front end as part of GNU compiler collection of GCC. That's what you guys need inside when we download the IDE. So what is IDE? IDE is integrated development environment. So we're going to be using the code blocks for this series, which is very common and very popular in open source, and it's cross platform. What is cross platform? It means you guys can use it for Windows, our Linux, our Mac, any other operating system. So Visual C++ is part of Visual Studio IDE. If you guys don't like this GNU compiler, whatever, you guys can always use this Visual C++ if you guys running Visual Studio Code. And the last one, we have a CLang. So as I said before, we are looking for this G++ front end, and we are using, because we're going to use the code blocks for this series, and the code blocks going to be looking for the GNU compiler collection of our easily you can see GCC. If you guys have trouble finding this GCC compiler, then we're gonna go through this one in depth, and we're gonna show you guys what's the alternative if you guys can find this GCC. Alright, so now we're gonna see how we're gonna install code blocks. So as I said previously, that you guys need the IDE. What's IDE? IDE is the environment where we're gonna run our C plus. And this code blocks is very powerful. As you guys gonna see here, is free C++, our Fortran IDE, built to meet the most demanding needs of its users. It's designed to be very extensible and fully configurable. Alright, so you guys need this one. So here, if you guys looking on the left, and if you are looking in your say here, codeblock.org. So this codeblocks.org is the website you guys need to go. So if you guys further having a look here, it's a download. So if you looking here, there is a few. If you guys wanna look at this migration or wiki, don't worry about this one. Just if you guys wanna go and download, just click on the download, and you guys gonna be here in the download. So download the binary release. You guys can go in the binary release. You guys can go here. So I've already done that. So if you guys looking here, it says if you are in binary release, it says Windows XP. You guys need to click this one, or you guys can go here. Now it says that code blocks 2003, so 20.03 setup.exe. There's two websites that's you guys can download it from. The first one, the website is called FOS, our FOSS Hub, our SourceForge, whatever you guys, if you guys like this website, you guys can go here and download this code block, or if you alternatively, you guys gonna go to SourceForge, and you guys gonna be downloading from here. So keep in mind, if you are if I'm here, and if you guys look in the corner, that's the website is gonna turn in. So if you guys look in the corner, it says https www forcehub.com. say code blocks here, that's a link here, that the links. So if I go on SourceForge, you guys gonna see here the SourceForge there. So if you guys go there, and as soon as you guys go in there, you guys, because I downloaded from here, I downloaded from the SourceForge, and I went there, and as soon as you guys gonna be clicking on the download, and it's gonna be start downloading in the system. So once it starts downloading from here, you guys gonna see here in the file, I mean here Firefox. So you guys gonna be seeing your downloads gonna be downloaded here. So keep in mind, it says that not the code blocks 20.03 Ming W setup.exe, that file. Additionally, GCC, as I said before, is a compiler. It's a compiler. GBD debugger from MingW. You guys needs to go here and install this one. So if you guys have difficulty this one, then I have alternative ones, so you guys can go and install. So once you guys go here, say SourceForge, or if you guys don't like this SourceForge, you guys can go ForceHub. Both of them is the same. Once you install this one, it's gonna go, and it's gonna go here in the it's going to be installing in your Firefox download here. So once you guys click this one, it's going to be downloading here. So, and you guys going to see it here inside the code block. So once you guys see this code blocks 20.03 setup.exe, you guys needs to come here and click this one, and then you guys gonna say just follow that one all the way, and then say there is a command call that says as it is, just press that one. So if we press this one here, so and then here you guys need to look at here, welcome to the code block setup, and once you go click next, and make sure you just press ID, agree, and once you press agree, it's gonna be asking say all plugins, if you guys want to install all plugins. So once you press next, and then here you guys looking here, if you guys looking here, that's your installation directory. So you see program files, code blocks, and this one's going to be downloading here. Once you press install, and the code blocks going to be installed, because I have already installed, I don't need to install it, but that's for you guys to install it. So, and once you guys install, then it's going to be asking you guys to say do you want to launch it. So once you guys going to launch it, you guys are going to see like this screen here. So once you guys going to see this screen, then you guys means you guys have successfully downloaded here. So I'll repeat again, you guys go here, either of these. So once you guys download it here, it's going to be coming here in your download folder. So this code blocks it's going to be exactly like this, code blocks 20.03 setup.exe. You guys double click here, the installation process, and you guys just follow, and then you guys going to be agree. Once you guys agree, and then you guys launch. Once it's done, and then you guys going to see like this screen. So once like this screen, it means you guys has downloaded your code block successfully. All right, so once you guys going to see this screen here, and you guys looking here, that's file, and we're going to go through all this later on. And then you guys, if you guys see here that compiler is not detected, it means you guys don't have compiler. So to find the compiler, you guys go here. So here inside the compiler here, once you guys in the compiler sign here, you guys going to see here global compiler setting here. So this sign here, global compiler setting. If you guys looking here, as I said in previously, that no GCC compiler, so that's what you guys need to know. But if you guys have say Visual Studio, if you guys know what you guys doing, or Borland, whatever, you guys go here. But in our case, in my case, we're gonna go here. So as you guys looking here, if you guys have gonna error message that your compiler can't find in, then you guys need to go here, toolchain executable. As you guys gonna see here, mine one is not a Ming, our you guys that's a different directory, even though I have installed this Ming, this guy here. So here I went there and installed this Ming. So here in my directory I have this one as well, but I have a TDM. So if I go in my C directory here, and if this is my C directory, you guys going to be looking here. I changed the name for Ming W, Min GW. So if I double click this one, I have this one here. So even if you guys have say Ming W here and it's not giving you guys error, it means you guys download it successfully, no problem. But in my case, because I had a trouble, so I have installed something else instead of this guy here. If you are looking here, if you guys can install this say Ming W, or for some reason your code blocks not detecting this one, you guys can go on alternative here. So what is alternative? Alternative is here. This is very easy. This is the same thing. This guy here, TDM GCC, is exactly the same as this Ming W, because I don't have internet connection. The reason you guys don't see anything here because I don't have internet connection. If I put the internet connection, this is going to be very slow. So that's why I turn off the internet connection. So I don't want to wait for too long. So here, this is the website for Ming W. So if you guys going to see here, you guys going to see here the download one. But if I'm here, I have came here TDM GCC. That's exactly the same one. That's I have pressed this one here, TDM 64 exe. So if you guys looking here, is that's a minimum online installer if you press this one. But if you press this one, is 64 32-bit Ming W W64 edition, include GCC, C, C++, GNU, and you guys going to see here all the compilers here that are listed here. If you guys have your computer is not 64-bit, you guys can go for this option, because this is only for 32-bit. But I think nowadays all the computers powerful, and every computer is 64-bit. But if you guys not sure, if you guys your computer is 64-bit or 32-bit, you guys can go here. So it means your computers, if you have a Windows 7, it means your if you have old one, say before 2010, it means 32-bit. But if you have after 2010, it means it's 64-bit. But check your computer if you have 64-bit or 32-bit. But I would recommend to you guys to install this one. So if you to install this one, just press this one, and it's gonna come here in your say downloads here. So here, as I guys gonna see here, first I have pressed this one, but because I had trouble, once you guys press this one, you guys gonna see here the RAR ones, the extractor. So once you guys gonna put extractor, it's gonna go here. But in the TDM 64 GCC, you guys don't need anything, because it's the file one, the extension one is exe. It means it's executable. It's gonna go in the C directory. So if I if I look at the name TDM64, and if I go in my C, I'm going to see it here. So here, as soon as it resides here, then when I came here and I put auto detect, it means it's straight away here. So it has all the C compilers. If you guys want to learn C is compiler here, then C++, and then linker, it has a linker, and linker for stereo library. So it has everything whatever you guys need to run your C++. And keep in mind that I'm gonna make C videos as well, so I'm gonna be looking for this C compiler. So this is for C. So if you guys have a trouble, as I said before, you guys can go for either. So if you guys go here for Ming W, you guys need because it's a zip file, you guys need the extractor. So you guys need to find extractor, and you guys double click that one, and it's gonna go in the C folder, in our program files, whatever you guys prefer here. So it's a Ming W here. I changed the name, so MINGW, because here it says sometime Ming W, but because I was having a trouble, so I came here, TDM GCC, looking at the website name. If you guys want to memorize this one, JMEU bank.github.io. So here I came here and I installed that one. So here now you guys can put that one here, and once this goes in your download folder here, in the download folder, so it's a seed here, then you guys can easily install that one. Once you guys double click, and make sure you guys download this one in your C folder. So if you are TDM GCC64, there is no need for any rename or anything. You just put it here, go here, just put auto detect, and it's going to detect it straight away. Once that one done, it means your code blocks is ready to go. So once you guys going to see this screen, and if you guys don't see any error, it means your code blocks is ready for action. Alright, so now that we have installed our code blocks, and we have successfully configured our code blocks, it's now for us to do our programming. How do we gonna do our programming? So if you guys look in here, create a new project. It says open an existing project, tip of the day, visit the code blocks for room, and report a bug. We guys not concerned about this one, or this one, or this one, or this one. We want this one. If you look in here underneath, it says log and others. So it says it's gonna show all the errors and everything, whatever bugs you guys have in your program. So this one helps to show you program, what's the status of the program, if the program running. So it shows inside the engine what's going on, because we are programmers, we are the mechanics. Here it says it's management. Here it means that's our workspace. All our folders going to be showing here. So on top, if you look in here, there is this it's called run and build and run. That's a build, or that's a run. There is a two part for the compiler. Is builds and it runs. So which sometime you guys want to build, you don't want to run, but or sometime you guys build and run. But this is the one which is very popular among programmers, because every programmer wants to build and run his program. What's a build? Because whatever the source code you guys have, the compiler is going to turn into the 00111s. That's how, because you guys going to build. Alright, so we're going to create our first project. So we, as I said before, we're going to create a new project. It says ERN project. We don't want that. We don't want this one. We don't want the fourth one. We want this one. It says console application. We want this console application because we want to see our programs, how our program runs. So that's first thing first is that we need in our program. So this console application helps us to see output of our program. So once you guys press go, it's gonna come here. Welcome to the new console application wizard. So if you guys don't want to see this one, you press this one. But I want to see this one all the time. So I press next. It says, do you guys want to C or C++? So because we are learning C++, so now in this screen you guys going to see here user C, users, home, documents. So why there is this one? So first one, you guys need to put your title here. The second one here, the folder to create project here. Why you guys need to create a folder? Say for example, by default this C++ gonna put, or whatever you guys gonna do practice, or whatever you guys gonna do programming, it's gonna put inside the documents. Say inside here, if on the left. So you guys can, if you guys don't create any folder, by all means you guys can do that, but it's gonna be higgledy-piggledy later on. How it's gonna be higgledy-piggledy? You guys gonna have a, say if you guys done 10, if you guys gonna see this all everywhere, if you guys gonna see everywhere, is gonna be all your projects. So in order to avoid that, we're gonna go here and we're gonna create my CPP project, for example. So if you guys gonna new, you guys gonna be coming a folder. So once you guys look in here, I'm gonna put I'm gonna put a C++, say project. Or you guys gonna put a my ABC project, my friend project, or my project. I love this project. You guys can put a ABC, XYZ, your cat's name or your pet's name, whatever you guys like. You guys can put it here as long as you guys remember. So we're gonna go here. How do we gonna go here in this project that we have just created inside this folder that we have just created? So we're gonna go here. There is a 3 dot here. If you look in here on here this side, not this one, just here on 3, this one, you guys double press that one, and then you guys gonna be looking the folder that we just created. So my C++ project. So if you look in here, that's our folder. So if you guys double click this one, it means we are here inside this project. So I'm gonna select a folder. You guys gonna put my CPP project. Doesn't wanna make difference. What's gonna make difference is project title. So I'm gonna put in my first project, say for example my first project or my first program. So I'm gonna put a program. So you guys, then once you guys finish, it means finish, then it's kind of asking for a compiler, which what's compiler, as we explained previously, we were looking for new GCC compiler. But if you guys don't like this one, and if you guys have a Visual Studio, or if you guys have something else, you're going to be looking for different one. But for in our case, we are looking for new GCC compiler. So once everything is done, and then we're gonna be pressing finish. And if you're looking here, my first program is residing here, as I said before, in this tray. If you are looking here inside your the folder that we just created here, my CPP project, my C++ project, and if you guys double click this one, looking here, my first program, we just created this one. So if you double click this one, you guys are going to see my main and my first program.cbp. You guys don't worry about this one, we are concerned about this one, main, because we are as compilers looking for main all the time. So what's the main? Main is the entrance of our folder, our program. So like the engine is say for example, what's the main entrance of the country is a capital. Say for example, in the case of America is Washington DC, in case of UK is London. Every country is like that. So and if you look in here, that's our folder that we just created here, my first program, and that's resides on my CPP C++ project. And we're going to come here. So as I said before, this is your tray where you're going to see all your debugging and all your logging. This guy here, looking here, there's a minus, and there is if I press this one, everything disappears. So it's minus, and again here, that's the main that I was talking about. So if you double click that one, you're going to see this here. Alright, so what we look in our screen, the first one, if you guys look in here, include IO stream. What is this? This IO stream is called preprocessor. So why this IO stream is here? Because without this one, the C++ is going to be C. So it's not going to be C++. Through this IO stream, input output stream, is that you guys going to be running your C++. So every program, whatever you guys make, it has to have this, including IO stream. If you guys don't put this IO stream, then your C++ program is not going to be run. So as I said before, that C++ is C with classes, so it's built on C, but it's one step ahead of C++, because it's object oriented. And you guys, for your C++ to run, you guys this looking at here, you guys hash include, and this less than and greater than, and you guys are going to see here this IO stream. So include IO stream statements include the input output stream header file content in your source file via the include directive. The IO stream header is part of the standard library. We need its inclusion to be able to use the std_cout object, also known as the standard output stream. So and then you guys going to be see here using namespace std. If you guys don't like this one, you guys can remove this one, and then you guys need to put std in front of all of these commands here. Say for example, if I remove this one, for example, using namespace std, then I'm gonna put a std in front of all with this guy here. This is the recommended way. So if you guys looking here, that's the first command of C++, cout, and then that's the end L, means end of the line. And if I put a std here, I put a scope resolution operator. A lot of people find this one is very cumbersome. They find it very bad. They think why I have to type so many things, but because you guys learning, and I want to show you guys the right way. Because now, why do we have int here? The reason we have int is for integer is this guy here, because I have a return 0. When you have return 0, it means we want the 0. We don't want any trouble in our program. If you guys want to put 1, it means your program have a problem. So we want 0. We don't want any problem in our program. As I said before, that std here, we need its inclusion to be able to use the std_out object, also known as standard output stream. And if you guys look in here, there is less than, this operator is called stream insertion operator. If you guys want to memorize that one, you guys can memorize that one. And it's called stream insertion operator. It inserts our hello world here, whatever is here, into the output stream. It inserts our hello world string literal into the output stream. A string literal is enclosed in double quotes. So there is a double quote here, string literal. So if you look in here at the end, NL, we have a semicolon, and this semicolon is going to finish our statement. This is called one statement here. So this one statement is going to be finished like this, just like when you guys writing here, we have a full stop. So but computers don't understand the full stop. They understand this one, especially C++. They understand this semicolon. It means when it's encountered, the compiler encountered this one, it means that's it. I'm not going to go move forward. So what we have learned this so far, the C++, that std is the standard library namespace. The std, this guy here, and this scope, this is called, this double colon is called scope resolution operator. If you guys want to change this one, hello world, hello, say for example from Crywood, for example from Crywood, you guys can change this one, hello from my side, or whatever you guys want to put it here. So here save everything, and as I said before, if you guys want to build, you're not going to see anything. If you guys want to run but you didn't build, but you guys press this one, build and run, and if you guys looking underneath here, your program start running. As I said previously, that our compiler is G++ exe, and that's here. So hello from Crywood. If you guys want to change this one to hello world, you guys can do so by all means. So hello world, hello from my first program. Well, you can do what you can write whatever you guys like. So here I'm here in build and run, and once I press build and run, my program is running now. So you guys looking here, I have a hello world on the screen. How cool is this? So this is our first program, and if you look in here, the process terminated with the status. That's a status, and that's how many seconds, 12 seconds it took to compile. And I think that's very quick, because if you guys, even if you guys put a large programs, it's going to be in 12 seconds, it's going to be compiled and it's going to be executed. So, and now this is called our source code. That's what is called source. The source code is this one, and the compiler and the linker is going to turn this one into 0011s inside the low level inside the hardware. So this guys, whatever we saw on the screen, it turned into 0011s. So as far as we are concerned about this one, not the 0011s, because we don't want to look inside the internals of the compilers or our computer program. We want to learn this one. We want to learn something that we understand. We don't want to learn 0011s. So that's how the C++ works, and that's how the first program runs. So now I'm going to introduce you guys the comments. What is comments in our program? When we work with C++, say for example in Office or anywhere else, so the best practice is that you guys leave always comments with your code. Why do we need comments? Because comments is one of the most important aspects of the programming. Say for example, if you're working in the Office, if you're writing a code, a big source code with hundreds of thousands of say functions or coding, then it's very hard for everyone else to understand your code. So unless you specify what you mean by this code, say for example, this is very clear because it's int main, because that's the ABC of say C++ programming. Is a main executable file. You guys can't miss this one. You guys even don't need a comment for this one because everyone understand this one. But what about if you guys do very complex programming, say for example for NASA, our very complex programming for making operating system like Linux or Windows or Mac, whatever, you guys need a comment. You guys have to put a comment. If you don't put a comment, then I don't know what to say. Then everyone's going to look at you and be wondering what your code means. Alright, so how do you going to put a comment? So when you guys gonna put a comment, so if for a single line, you guys just put a double this one, double /. So I'm gonna put it this is my comment. So when I put this one and I go and save, I run my program, say I build and run, and you guys gonna see here that code blocks is just gonna, the compiler is just gonna ignore this line here. But if I put some lines here, then the compiler is going to be extremely angry if I don't put this forward slashes. So looking here, the compiler just ignored. Imagine if you guys don't put this one here, and now if you guys gonna save, and now the compiler is going to be extremely frustrated because the compiler is going to look at this one as a code. This if you look in here, it says this does not make a type. It means this nothing. What do you mean by this one? I don't understand this one. This is just something that is not gonna make sense, because the compiler is just a machine, so they don't understand this one unless you guys specify what you mean by this one. So you guys can put as many as this forward slashes as you guys like. Say you guys put it, this is my first program, and every time you guys gonna put this one, you guys gonna be seeing that the compiler is just gonna ignore this line. So if you guys have say making more lines, you guys can change this one. Instead of say single lines forward slash, you guys can put a, say for example, if I come here and if I put a say now star, and then look how you guys look in here, the colors changed. If I put another star and forward slash, it means it's came back. Why? Because that's for multi-line. This one you can put as many comments as like. Say you guys gonna put a, this is my first line, then second line, then third line, whatever you guys want to put it here. This is your playground. If you guys put it this way, for your comments, and compiler is simply going to ignore this one. So hello world is, you look here, the compiler has just ignored all of this. That's a single line comments. If anyone asks you what's the forward slash means, if you guys want to put one line, say for example something cheeky or some one line express your thing, you express your program, you guys just put it here. But if you guys have more, you can put it here like that. Just put a one forward slash, put a star, and then a forward slash, put a star here like that. And keep in mind, every single programming languages that you guys going to encounter, PHP, be it Java, C#, R, or Python, whatever you guys think of JavaScript, that's exactly same convention here. Forward slash for single, and this one forward slash star for multi-line. You guys can put up to 20 line, 30 line, 40 line, whatever line you guys want to put it here. The C# the C++ is just going to ignore this one, because as soon as the compilers encounter this one, it means I have to ignore this one, and it just disregards this one. But if you guys don't put here, then the C++ is going to be extremely angry on you guys, because this one now, the C++ going to see this one as a code. It's not going to see this one as a comment, because now you're looking here, this was not declared in this scope. This, it doesn't make any sense. This our this one, it's not going to make. So looking here, the compiler is going to be extremely angry. But as soon as you guys gonna change this one, then C++ gonna be very happy. So if I build and run, and you guys gonna see here that the C++ is just gonna ignore this one, and your program is gonna be flowing very smoothly without any error. Now we're gonna talk about escape sequence. So I'm gonna put it on top. We're gonna learn about escape sequence. Okay, so we're gonna control S to save. Okay, so now we are gonna little bit zoom in, because if you guys have a difficulty to zoom in, if you guys look in here, it's a zoom in, but if you press, it's not gonna work because this is a code block. So you guys gonna go on edit if you guys want to make your font bigger, and if you guys look in here, it says special command, it says movement, it says zoom. If you guys want to put it in, you guys can zoom in. If you guys want to make it bigger, say if you guys want to bring this one down, you can bring it down, because at the moment our program runs perfect. There's no need for this one. But if I go here again, and if I put special commands, and if I put a zoom in, I'm gonna see, you guys gonna see it a little bit better. But if I want to do it again, so every time I need to zoom in, I go in here, special commands, and look in here, that's a line, and that's a zoom in, and I think that's a lot better than before. So if I do one more time, I'm gonna go here, special commands, zoom in. I think you guys gonna see it now a lot better. Alright, so now as I said before, we're going to see this escape sequence. So what is escape sequence? So escape sequences in C++ are characters or sequence of characters that can be used inside a string literal to represent some special characters. So they are prefixed with backslash and are used to represent characters such as new line and carries return that cannot be represented normally. So don't confuse this one with this one, because that's a forward slash. That's forward slash. We are looking for the backslash. So if you put, say for example, you can put inside here, say if you put this forward slash, it's going to be totally different. But if I put a forward slash as I put in comment, it's going to be showing me inside here. So now if I want to run, this forward slash means nothing for C++. But if you guys wanna this escape sequence, you guys need to put a backslash, as you guys gonna see here, hello forward slash. You guys but if you guys don't want to see this one, it's a backslash. Say for example, now we have a string, for example literal string, this is Michael's property. Okay, so if you look in here, I have a double one on the two sides and there is a single one. So how about if I have three single ones? Say for example, now C++ can distinguish that I have two double quotes here and I have a single quotes. So C++ gonna run this one. So we're gonna test, because I have a two double here and the single ones in between. But this one is nowadays is no problem for the computer, for the C++ compilers to learn to know that there is what I mean here, what I mean here is like some sort of properties. But back then, in the old times, this was a big problem. This is not the only use for this one. As I said, it has the two here, because there is a single one. So now C++ gonna easily distinguish this one. So how about if you guys want to use it, say for example this escape sequence, other one, say for example now if you want a two line, say for example now Michael's, say I'm gonna put this is the first line, this is first line. So how about I'll go to put this one second line, this is second line. How I'm going to do that? If I want to put this one here to second line, then I'm going to come here at the escape sequence, put a backslash and put an n. And now you're going to tell me, how about if the user can see this one? The user not going to see this one because there is a escape sequence and there is a next line here, n here. The user is not going to see here. The user is going to see two line. And if you put a more, the user is going to see more here. It works with every programming language on existence nowadays. It works with Python. See here, this my first line and this is the second line. So even if you put here, say for example another one, this is my third line. You can put it. This is my third line. So here now, if you press, this is going to be my first line, second line, and it's going to be my third line, because we have escape sequence. If you guys wanna put a say, you guys can put a say some sort of bell. If you guys wanna put a bell, you guys can put a bell. Say if you put a, if you guys wanna sing our song, say for example, beautiful day, for example. So what this one does, is this one's gonna say rings a bell. Say for example, whatever is the bell default you have in your computer, this is gonna, and you guys heard the bell, because the default bell, it calls the your operating system's default bell. How about if you guys want to use for example tab? You guys can use a tab, because this escape sequences help you guys to do wonderful things. Say for example, now if you guys want to put a say tab in between. Tab, what is tab? Tab is, if you're looking on your screen on the left hand side where it says Control Shift caps lock, the tabs there. Tabs 4 spaces. Say if I put a 1 2 3 4, that's a tab. Say if you want to put a hello, say programming, or you guys can put a C programming or Python programming. Say for example, now if you want to put a in normal ones, it's gonna come here side by side, but if you put a escape sequence T, it's gonna be, say for example, one tab, it's gonna be 4 spaces. So that's one here, hello programming. So if you can look in here, there is 4 spaces between. So if you put your thing here and count 1 2 3 4, one tab here, that's our T, escape sequence. How about, as I said before, you guys say wanna, instead of this one, you guys want to put it side by side. You guys can put it side by side as well. Say I love, say for example, C++. I like C++, and then you guys want to put a I like, say I'm gonna copy that one and I'm gonna put here I like, say for example, C. Now as I see, as you guys looking here, it's got an end L. We're going to remove the end L. You don't want an end L here, because end L is end of the line. You can remove that, and make sure you put this one comma at the end of your statement. So how are we going to show this one in one line? We're going to put the escape sequence V. So now you're looking here, escape sequence V, and if you're looking here, it's going to come in one line. See here, I like C, I like C++, I like C. And how about if you have say for example 3, say for example now if you want to put say 3 of this double quotes, say for example Biden, President Biden says, and if you guys want to put a quote, then it's going to be one quote for example or something, you guys going to put that one. Say go behind it, put 1, and say for example our President Trump says for example, I am fine, I am fine. That's why you guys can use that one, this one for quotation. Say if you want to put here, you guys still gonna see here President Biden says I am fine. This one is more mainly used for quotation. So you guys looking here, I've got this quotation as well, but if you guys wanna say put it in the next line, you guys can put this one and backslash, and say now if I put a backslash and here, now I'm gonna see in 2 lines here. As now you guys should be able, so you hear Biden says I am fine, because that's for quotation. I like C, because that's I'm using that double sequence. You guys can use as many as you guys like. Say for example, you guys can now use the T, which is going to be for tab. You guys can put an N, but this is very widely used, because sometimes you guys want to put it on top of each other, or sometimes you guys want to put this one in quotation as quotation. Someone said, or a president said, or prime minister said this one, you guys, because you guys want to reference that one to the person that is the source of that word, or the source of that sentence. Say for example, if you want to quote that one, this is the best way, escape sequence, because literal strings are made for strings. This is string, and what the creators of the C++ done is to create this one. So now we have a way to express, to do programming with ease. Without this ones, programming is going to be very hard. Alright, so now what we have learned so far, if looking here, we have learned include. We put it here, include IO stream, which is the big backbone of C++. Without this one we cannot run any of this here inside here. It's just going to be a skeleton int main, which is C. As we said that the C is extension of C, so plus plus is one step ahead of C. Then we have seen here int, which we're going to discuss now, and we have said that the main is the main area of C++, which gets executed. This is quickly bracket open and close is called block. So inside here we have std double colon C out, and this is std stand for standard. This guy is here is called scope resolution operator, and this is C out. So without this guy is here, it means nothing to the computer. This one here is the everything's written in this guy is here in top, which we call the preprocessor. As the name suggests, it processor first, then the computer understand that this is C++. So this guy here is called standard output stream, and this less than is called stream insertion operator. And we said that the statements are pieces of C++ program that gets executed, which ends with the semicolon, and this guy is here. And the std is the standard library namespace, and double colon is the scope resolution operator. That's guy you guys need to remember. And at the end we have a return 0. So without this guy here, int means integer is taken from mathematics. It means we can if you put an int here, we can return it to 0. Otherwise, if you don't put an int, if you put a string or any other data type, we cannot put the 0 here. So the reason we put a 0 here is because we have int here. And 0 means our program is going to be okay. If you guys see 1, it means your programs have a problem. So that's how we program in C++. So now we're going to see types. So if I remove this escape sequence and we put a types. What is types in C++? In C++ we have 5 important data types. The first one is a Boolean. The second one is a character type. The third one is the integer type. The fourth one is floating point types, and the last one is a type void. And we're gonna discuss that extensively with you guys. All right. So as we said, the first one is the Boolean data types. So we put a Boolean types. Simply we call it types. You can put a data types as well. So how are we going to declare the Boolean types? So with the Boolean, you guys need to come here and declare here inside your block. You just put a bool, for example XYZ, or for example B. You can call it B, or you can call it A, or we can call it whatever you guys like. So now we have declared our data type. The first one is B. As you guys know that the C++ is a statically typed language. It means if you guys want to use this bool anywhere inside your program, say for example this guy is here, you guys need to declare it, just like walking to airport and declare all your belongings. So that's exactly same with programming. With the programming, you guys need to declare your data types here. So C++ demands to know what sort of data types you guys want to declare. If you don't declare your data type, say for example here, or if you want to use it later on, then your program is going to crash, because the compiler wants to come here. The compiler is going to come here and want to look for the data types. What sort of data types you guys want to use here? So keep in mind the Boolean types, character types, integer types, floating point types, and type void. They all is called fundamental data types. So what is fundamental data types? So C++ has some built-in types. We often refer them to as fundamental types. So fundamental types declaration is a statement that introduces name into the current scope. This is what we are talking about. So now we are declaring the variable B of a type bool. This type holds the value true or false. This Boolean is in honor of the George Boole, which was a mathematician, and this Boolean describes as a true and false. True or false, for example. And can you believe it or not, the entire computer industry is standing on this true and false. Everywhere you go, even you do transactions, your say for example you go in the shop and buy something, and that the machine sends a bool types to the bank. It says either this guy has enough money inside the bank or not. So the bank sends either 0 or 1, for inside the computer, true is 1 and false is 0. So inside the computer we represent true as 1 and false as 0. As we said before, that our example declares a variable b of type bool, that is, the variable is not initialized and no value has been assigned to the time of the construction. To initialize a variable, we use assignment operator followed by initializer. So if you guys want to initialize this one, you guys need to put a this guy here. It's not an equal to in mathematics, but this is called assignment. So what we want to, you guys, for example, you want to put this one bool b is false. This is one way of declaring your Boolean data types. There is another way. If you put a bool and for example a, and you guys need to open a bracket and close bracket, and we put it true. This is another way. So we have a two-way. This is old way of when we declare our data type here of type bool, and we name it b, and we put equal sign means assignment, and here we put a true or false. And keep in mind here, the second way is we put a bool and we name it a, and we open a squiggly bracket and close it, the block, and we put a true or false, whatever you guys want to put it here. The second one, as I said before, the second one of the fundamental data types is the character types. So how we represent these character types in C++? So as character type, we put a char. Char is character types in C. Say for example we name it C, or you can name anything you guys like. So the type char, which we name it C, is referred to as a character type, is used to represent a single character. The type can store a character such as A, B, C, X, Y, Z. The size of the character type is exactly 1 byte. So the character literals are enclosed in single quotes. In C++, to declare and initialize a variable of the char, we write it char and we put a name C, or if you guys want to say assign something, you guys need to put a assignment operator. So if you guys want to say for example char C, you can put it here, for example here, and put a single quote and put a Y, for example, because it takes only one here, only one character. You can put A, B, C, any alphabet you guys put inside here. So if you put it here, if you guys want to know how I type this, how I assign this Y to C, you can put it here. So you have type, you can put a you have typed, and then what we have typed, and then we're gonna get out of here and put a stream insertion operator, and then we put a C. If you guys want to know what you have typed, so inside here is a literal string. Inside here, keep in mind we represent the character with a single one and a string with a double quote here. So this is inside here it's called a string. This is a string. So here we have put a string here. A string means many characters. So when the computer was invented, we could have only put one character at a time. But then the programmers have excelled in this game, and they invented this stream. So a stream is an array of characters. Keep in mind, it's a lot of characters. You can call it a string. So now if you guys want to know, just come here and save all your file, and we're gonna go here, build and run, and we're gonna see our program. And now we're gonna see here we have typed Y, because that's our character here. Alright, so the next one is called integer types, or simply we call it int. So I'm gonna put it here, integer types. And integer type, you guys have noticed here that in main we have integer type of we can call it int. Simple, we can call it int. Int, if you don't have this one here, then we wouldn't have this one here. Without this one, the computer would give you error. So how we going to declare our integer? Integer, you guys don't need to put integer, you just put an int. Int, for example, we can call it x, and our x, say for example 100. This is called int. So we put a std, it's called resolution operator, cout, and it said your int value is, and here we put our int value, which is x. Now if you want to run, then we're gonna put a backslash n if you guys want to see the next line, otherwise you're gonna show you guys in the same line. So we're gonna go save our file, Control S, and we're gonna run, and we're gonna see our integer type. So we're gonna see here you have typed, and then you're gonna see here y in this line. So y we're going to see in this line, and then your int value is 100. The reason is because we didn't put say the next line, we put our next line here, so that's wrong. So if you want to come here, put a stream insertion operator here, we put again double quote, and we put an n here. So now if you save the file, and if you look in here and we run, now we're going to see that our output is the correct format. So we have typed, you have typed this guy here, and the value is 100. So here you guys can do this way. So once we declare a variable, we access and manipulate the variable name by its name only, without the type name. I'm referring here, once you guys declared and assign something to your variable here, then you guys can declare it inside here. You guys don't need to put a integer all the time here. You just use the name. Say for example, now we are using just the name. You guys don't need to use the char here or type here. We only declared once, and that's it. So after once you guys declared here inside your declaration here, then we can just keep on using it without even ever specifying. So now C++ knows that this C is a char here, our type character. So integer types, our simply we call it integer literals. Can be a decimal, it can be octal, and can be hexadecimal. So octal literals is started with the O. If you see something started with the O, is octal. We humans, as we already know the numbers, which is integer type, but inside the computers we have an octal as well. It's called octal, and we have a hexadecimal as well. So if you put hexadecimal, so octal inside the computer we put it as O, and hexadecimal put a big O or 0 multiply, then we put an X A. That's what sometimes you guys going to see inside when your computer gives error. You guys going to see this character here. Say then there's going to be some numbers here. So hexadecimal, this is called hexadecimal. It starts with O, then X, and then A means it's hexadecimal inside the computer. And when you see O and see some numbers, it means that's octal. And all of them is integer types inside the computer. As far as computer is concerned, they're all types integer inside the computer. So the next data types that we're going to come in see is called floating point value. So what is floating point value? So I'm going to put it here as floating. There are 3 floating point values in C++. The first one is a float, double, and long double. So we have a float, and we have a double, and we have a long double. If you have a very small character here, you can put a float, for example. And if you have a very long number, if you can put a double. That's for banks and stock exchange. If you have trillions and trillions and trillions of a lot of numbers, then you guys going to use a long double. That's how the memory takes. As I said before, there are 3 floating types in C++. The first one is float, then we say double and long double. Mainly we are using the type double precision. We use it for storing float point values of real numbers. And if you guys want to put a double, for example, we put a double, and then whatever double D, and then you name it D, and you can put your number. So how we're going to put number? We can put a, say for example 300.50, for example. Now if you look in here, I didn't put any point here inside here 100. If you put a point, you're going to get an error. But if you use double our float, double our long double, then you guys are allowed to put this point here, point value. So 300.50, you can put, you're allowed to put a dot in between. Now this one here, the next one is going to be type void. We put a type void. So the type void is a type with no values, and that's the only purpose of this value. So for example, inside the computer you have all these types. What happens if you guys don't need a type? And that's how the computer programmers, they come in and invented this void. This void means nothing. So if you guys think this is an object of type void, you're wrong. That's not an object. Now we say that the type void is a type with no values. Well, what is the purpose of such a type if we cannot have objects of the type? If you want to declare, for example, this one here, we put an int, for example, then we put a void here, for example, inside your programs. So you don't need to put inside the main, but as I'm saying, once we get to the function, I'm going to show you guys how to put a void here. So once you put a void on top, then you don't need to put this one here. So if you put this one, then you're going to come in clash with the computer. Say for example, now if you want to, for example, just tell the computer that I don't need this return with my function. For example, you can put a int void, for example, draw. That's your function, and we're going to come to the function later on. But now the computer understand that int void draw, it means that you guys just want to draw. You guys don't want to return anything, because now we are requesting return. So return something is a true or false. But in this case, we are not interested in returning. You're just telling the computer to keep in mind that we have a function called draw and it's type void. It means we don't want any return value here. And the last one, we have type modifiers. So type modifiers here, I'm going to put it here. Type modifiers. So types can have modifiers. Some of the modifiers are signed and unsigned. The signed ones means that the type can hold both positive and negative values, and unsigned means that the type has unsigned representation. Other modifiers affect the type size. Short means that the type have a width of at least 16 bit, and long means that the type will have at least width of 32 bits. Furthermore, we can now combine these modifiers. Now if you want to go, as I said before, we have a signed and unsigned. So we put unsigned, and say if you put a long int, we call it ABC, whatever here, ABC X. So we have used, we put it ABCD, we put it D here. So D, and we assign some number. Say for example, we put 50,000, for example, or 500,000, for example. So we put this number here. Now we're going to come here, put the next line stream insertion operator, and here we put a \n escape sequence that we have just learned. We put a std cout, and we put a stream insertion operator, and we put the value here. We put the value of long int is, and here we just put a stream insertion operator followed by D, and you guys needs to come here. So we're going to look for the name, and it's a D X A B C, and then for example we put a F, for example F. Make sure it's not the same here again, and we're going to change, make sure this line, because we put it here D, we're going to change this one as say F, for example. So F here, and this name is, we already use it here, and we use it here. So save, and we build and run. Alright, so now we have put the type Y, that's a character, this is an int, and this one is unsigned long int. That's our number which is showing on here on the console. So this is types in C++. So we're gonna go again on this one. Again we have a types, we have a boolean type which is true and false. We have a character type which we can put only one character here. We have integer types, which we have a type int, and we can, inside the computer we have an octal, which is O, hexadecimal, which is OXA, and then we have a floating point types, which is float double and long double. Make sure you can put a, say for example, point in between. We have a type void. It means we don't want to return anything, which it means void. Void in English, it means nothing. And we have type modifier, which is a sign and unsigned here. So sign and unsigned. Alright, so now we're going to talk about the variable declaration. We talk about the definition and initialization. So far, if you guys know, here we have discussed about type, which is the data types. We put a name and we put a true or false here. We assign some sort of some sort of number, our character, our you guys gonna see here that some sort of value. So introducing a name into a current scope is called the declaration. We are letting the world know there is a name. So for example, a variable of some type from now on in the current scope. In declaration, we prepend the variable name with the type name declaration example. And you guys know here that we have put a here variable name, and we put a name and we put either true or false, but it's a type boolean here. So I'm going to remove all this on top because I'm going to make it very easy. So now what we have say for example char, and we put a C here. We declare it and we don't put any value here. Say for example we put int a, we put a b, and we already put a d, for example. We can do like this too. If you guys wanna have just put the type here and just put 3 here names here. You don't need to put a one at a time, otherwise it's going to take a long time for you guys to put something. You guys can put 10 in a row here, and say for example we put a double, we put a d, we put an x, for example. So this is called declaration, because we are declaring here. So what about the initializing? So if there is a initializer for object present, we can call it initialization. We are declaring an initializing object to a specific value. We can initialize the object in various ways. As I said before, we can say for example we can put an x, for example int x, and we assign some sort of value, for example 300. Our we can put an int for example xy, and we can put this one here. We can put our say for example 400 here. We can do this way as well. Our we can do here for example int, x y z, and we put some sort of we put this guy here, and we put assign some sort of number here. So for example we put a 700, for example. All of them is okay with the C++. All of them is accepted, no problem. So now this there are 3 variables here. Here the first one is that we are declaring. If you guys put a, say for example int a, it means you are declaring. So if you guys want a definition, for example we can put a char c. Our we can say we define it, for example we put a y. Now you guys know here, and we put a y. So this guy here is the declaration. Now this guy here is the definition. Now here this guy is here, we put a some sort of value. It means we are initializing this one. And if you guys want to look at the value, you guys can type this one, just use the name. So we cannot use this one because this one doesn't have a value. So this type, the types and the names come on the left side. If you guys want to assign this one, and this is assignment, and this is a, keep in mind this is operator, and we are assigning some sort of value here. So we have so far done a declaration, we have done a definition, and we have done initialization. This is called initialization. You can see in C++ many programs in different ways. You can put it that way, that way, that way. All of them is acceptable in C++. Alright, so now we begin with the operators. What is actually operators? In the previously we have described these guys here. This is that look like here we are assigning some value on the right. to the value on the left. So here if you look here, we have no assignment here, but if you look in here, as I said before, that if you put a single equal, it means you guys are assigning something, and it means you guys giving some value. So if you have $1 in hand, and if I'll give you another $2, you're gonna have $3. So it means you have $3. So you can imagine that you have a $3 here, and that is you on the right, on the left hand side. So that's how we assign operators. So that's how the assignment operator works. Say for example, if we remove all this, if I put a int, for example a, and I'm gonna assign 100 to a, it means that now I have assigned 100 to a. Say for example, now you can assign again a, so make it 500. So you can change the value at will. So as it's up to you. If you guys want to change the value, you can change the value. Say for example, now you guys want to assign a character, say for example C, you put it for character, and you can put a character C, for example. Just put a single quote here inside this guy here, you just put it here. If you want to put a string, you can put a string. If you guys want to put a double, you can put a double. So this is called assignment operator in C++. The next one is going to be arithmetic operators. And arithmetic operators is going to come as a plus. We already know that we are aware of arithmetic operators. It's come minus or subtraction. It comes at multiplication with the star in computers, and slash, it means it's division, and modulo, the last one. Modulo is a remainder, if you guys don't know modulo. So we can do we can perform all sorts of arithmetic operators. Say for example, if you guys want to put an int, say a, and you guys want to assign some sort of value, I'm going to assign 100. So we're going to put an int, say b, we're going to assign say another say 200. Now we put an int, for example, we're going to put a result, for example. What is the result here? So what are you guys going to do here? So this guy is here. Now here we have assigned 100 to this guy here, from the right side to this guy here, a. So we're going to put an a here. If you guys want to put a say plus, you guys can put a plus. So what about here on the b side, on this side here, the bottom one's b. You just don't put a 200, you just put a b here. So we're going to put a b here, and here we're going to remove all, and we're going to put a say the result is, say the result is, and you can put a result here. That's it. So we put a result, and here you need to remove this because we don't have any other line here. So once this one is gone, we can save all our control S, and we can build and run our program. So we have made a mistake here, we didn't put our assignment operator, and we're going to save all again, and we're going to run our program. And if you guys observe here, we have 300 here. So how about if you put a say for example multiplication? We can put a multiplication. It's going to be a huge number, so we're going to run, and you're going to see here there's 20,000. How about we put a negation? Say for example, if you put a subtraction, so here we're going to subtract this one's a from b, and you're going to see here's minus 100. Say for example, now if you divide this one, we're going to get some weird number. So I'm going to run that one again, and it's the result is 0. What is modulo? Modulo is a remainder. Say for example, if you divide some numbers, in whatever remain, it's going to be remainder. Say for example, you have put a 10 here, and if you put a 3 here, say for example they tries to divide this one 10 by 3, whatever is the remainder is, you're going to get the remainder. Say now if I put a modulo here, and we're going to run, we're going to see what's the remainder of say a to b. So for example, what's the remainder of 3 so to 10? So this b tries to divide this 10 into 3 into equal pieces. So 339, and if can 339, and what remainder is 1. Doesn't matter what number you guys going to do, you're going to get remainder. Say whatever you put it here, the number it tries to divide. If you put a 9, you get a remainder of 0. So if I change this one to 9, I'm going to get a remainder of 0, because this guys here, they try to divide this one into equal pieces, and you're going to get 0, because 3 times 3 is 9, and you're going to observe, if you observe here, you're going to get 0. And the next one is we're going to see is compound assignment operators. So compound assignment operators allows us to perform an arithmetic operations and assign a result with an operator. Now if you put it here, if we remove these guys here, and we remove these guys as well, you guys don't need to put that one here. Say now we put a, for example, we leave it to 9, and we're gonna put some compound assignment operator. We put a, because we already defined this one here. You guys don't need to define again if you are using the same character here. So we put a plus equal to, and we put say 10 on top. Keep in mind, you guys need to put a, instead of result, because we don't have a result, we just put a we just put this number here. So here now if you build and run, you get a 19. So how do we get a 19 here with the compound assignment operator? If you I put a comments here, this one is exactly here is like a which is equal to say a which is 9 plus 10. That this one is exactly like that. So here I have this a, which is this guy here, and if you put a compound assignment operator here, is automatically say increments that one, because here that's how the assignment operator works. That's this guy here and this guy here is exactly the same. So instead of putting a equal to and assign this one here, which is a 9, this one holds a 9 value plus 10, which is the new value. Instead of putting this one, we put it in shorthand. That's how we put it here. So if you put a, say for example, now if you put a minus, you're going to get exactly the whatever you guys you're looking for the result. Say for example, you get -1. If you for example multiply it here, we can multiply it and just put a save, and we're going to get a multiplication now. Say it's 90. Same as divide this one, we can do division except modulo. We don't do modulo in this one, and this one is 0, because modulo is a remainder. If you guys remember the last one, I've done this modulo and I get a remainder, because with this compound assignment operators we don't do modulo. So just keep in mind it's a compound assignment operator. I'm missing O here, so that's a compound assignment operator. So the last but not least is we're going to see as increment and decrement operators. So we put an increment or we put a decrement operators. So what's increment and decrement operators? Increment or decrement operators increments or decrements the value of the object. So the operators are, say for example, we have seen the compound assignment operators, but this one is totally different. Say for example now a is equal to 9, or you guys can put a 10 for example. Say now if you want to put a LU value, say for example if you do pre-increment, it's called pre-increment, and then we have a post increment. So we put a 2 plus and we put the value a, and similarly post increments is we put a, for example our XYZ, we put a double plus at the front, and both of these cases it adds 1 at the front. So for example now if you want to say for example put a in pre-increment, we put a, and if you look at the result, it's going to show you guys 11, sorry, it's going to show you guys 11 because we have a value of 10 and we have added 1. So how about if I do the post increment? So if I put a, if I put a double plus, and if I'm going to run again, I'm going to see 11 again. So how about if you put a pre-decrement and post-decrement? Say for example, now the opposite of increment, we have a decrement. Say for example, now if I put a zeros, minus minus, and if I run it, and if I'm going to see it's 9. Say for example, now if I put a, and if I put a minus minus, I'm going to put it here as 9 here. So we have seen that both pre-increment and post-increment operators add 1 to the value of our object, and both pre-decrement and post-decrement operators subtract 1 from the value of our object. The difference between the two, apart from the implementation mechanism, is that with the pre-increment operator, a value of 1 is added first, and then the variable, our object, we can say object, is evaluated or accessed in the expression. With the post increments, the object is evaluated first, and after that the value of 1 is added to the next statement that follows. It does not make a difference. So the value of object is the same no matter what version of the operator was used. The only difference is the timing and expression where it is used. Alright, so now I'm gonna remove everything here, and we're gonna see how we're gonna get our input. Say here, and I'm gonna remove this one as well, because we have seen already the compound assignment operator and increment decrement operator. So far we have seen a C out, means C is going to getting out, but keep in mind that C++ have another standard input output, because IO input output, because we have output as well. It means C out, and we have another one is called C in. So this out is here, IO, and we have a C in again here. So how do we gonna get say result from the number from the user? So if you guys remove this one and put it here, and you put it something for the user, please type something. Please enter number, or you can put enter some number. So when you put this one, it's going to prompt for the user to put something. Then you guys need to put it int, because we're gonna we're gonna accept int from the user, and we're gonna put some sort of value, for example, and we put a 0. So we are gonna initialize this one from the 0. So now whatever the user is gonna put it here. So we put a std, scope resolution operator, and we put a c in, and this guy is here. Keep in mind, just observe here is a less than, but this one is greater than. So whatever so far we have learned that whatever the values on the right side, we're gonna put it out, but now it's gonna be the other way around. So whatever the value is gonna put a user, we're gonna put it, assign it to the variable here. So this guy here. So that's what we're gonna put a and std, and we put a c out. And what we're gonna put a you entered, we put a you entered whatever the numbers user is gonna be enter, and what is this value here? This value is gonna be a here. So we're gonna control we're gonna put a control S to save. You guys can press this guy here. Now we're gonna run our program. So we're gonna put some number. Our number is going to be, say for example, 3. So now the compiler got the value, and put it here in print it on the screen. So what just happened here? So here we are asking the user to put some number, and here we are creating some sort of variable, and we are assigning 0 to it, because we're going to initialize with 0. So now the C in works opposite to the C out, because this one is going to put output. Now we're going to put input inverse. So whatever the user is going to put here behind the scenes, because it's not going to show, the only thing the user is going to see this line and this line, because a C out and a C out, the user is not going to see the C in. Whatever the value is going to put here, the compiler C++ is going to assign to A, and we simply is going to see the A. So this is called standard input in C++. Now we can put some instead of some number, we can put say multiple number, for example. Now keep in mind numbers. So C++ have also the functionality to accept two numbers instead of one number. So here now we have int A, we can put an int, for example, B. So now we're going to initialize to 0. So how about now we have put it here A and B, because we're going to accept two number. Now the C++ going to reserve room right here inside the memory of your computer for one slot for A and one slot for B. So now if you have a one value here, and now we have added another one, how do we going to put a sign here? Say previously we put a std standard, and then we put a scope resolution operator, put a C in, and we put a stream insertion operator here. So now you guys need to put another stream insertion operator and put a B here. So you put a A, you have entered this guy here, the A, and you can put it even underneath, or you can put it on top. So you can put a copy, and here you can put a B here, and you can put a B. If you want to see it in another say line, the next line you guys need to put a here, say escape sequence, and put the next line if you want to see your B. And now I'm going to run, and I'm going to explain what. So what I'm missing here is this guy here, end of line. Keep in mind whatever variables you guys need to put in must be closed by this guy here. So now we're going to run our program again, and please enter multiple numbers. So the first one I'm going to put a 20, and I'm going to put a space. The second one I'm going to put a 30. So you enter 20 and you're going to put a 30. It doesn't matter how many you guys are going to put. You can even put up to 3. So you can put a C and assign 0 and add just one more here, and make sure you just put some sort of mechanism for for the C++ to accept some value here. So as I said before, that you guys can put a 3 here. You can put a, say for example, you don't need to put just a number. For example, we can put a enter something here, for example. Now we're going to go on something. Okay, so the first one is that we're going to go say A, and put an int. The second one is here, we put a character, say for example char. So we put a char, and we put a C. The third one, say for example, we put a double or float. So we put a double D. So now we have 3 instead of say 1 here. So if you're going to put it here A, and then we're going to put a B, which is character. Now we're going to put a say here, we put a D here. You can divide this one, but your program is going to get bigger and bigger and bigger. So you can put a here, this guy here, and now you guys need to put this one accordingly. You guys need to fix this one. So if this one's A and this one's going to be C, because it's character, and this one's going to be D. Okay, so the first one is A. Keep in mind we're going to assign a value here. The second one C, we're going to assign some value here. That this one's guy is going to be D. So this guy is character, so we put this one here C, and this one's going to be D here. Okay, so now we're gonna put some sort of line here. So now we're gonna put a escape sequence, next line, Control S to save, and we're gonna run our program. So now we're gonna put a int, character, and double. So the first one's gonna be 10, 100 for example, then the character is gonna be S, and the double is gonna be 400.1. Now you're looking here, the first one we put an int 100, then we put a character, then we put a 400 per 1. So now in this in our program we are accepting 3 values instead of 1. This is getting more and more complicated, so I hope you guys not getting dizzy. So this guy here, now you guys gonna look here that now we are accepting 3. But if you guys wanna say, for example, ask specifically user put character or put this one, then you guys needs to put a say C out here, please enter say integer, or then you guys need to put another C in underneath and put on top, direct the user to put a character. But because we are learning here, it doesn't matter, we are just putting straight here. It makes no difference, because now because we are programming and we are learning, so this way is a lot quicker and a lot easier for me to explain. Alright, so now we're gonna use the same program, and we're gonna make some sort of calculator. So we're gonna ask the user, please enter something to calculate, for example, to enter some number. We're gonna ask the user to put some sort of a number. We're gonna calculate that one. So now we're gonna put a int. Say we have we're gonna put a b, or we're gonna put int x, for example, and we put int y, for example. We are not going to assign to 0, just put a say just x and y, because we want to ask the user to put some sort of number. So we're going to put x here, and then the next one is going to be y. Alright, so now here we're going to remove this guys here, and we're going to put another variable. It's going to we're going to put some sort of result, or for example, we're going to, instead of result, you can put int z, for example, z. And now what we're going to do, what sort of arithmetic you guys want to perform. You guys want to put addition or subtraction. We're going to put x, for example, plus y. That's what we want to do. So your number is, so we put your the result is, for example, we want to see the result, and what's the result? We have stored it here in z. So now I'll explain this one. We are prompting something for the user to enter something. Now we have 2 variable. We declare x and we declare y. Here, as I said, C in is going to take some value for x and y. So here we're going to create another variable. We call it z, or you can call it, you can put a result, whatever you guys want to put it, and we're going to perform some sort of arithmetic operations here. The first one is we're going to put a plus here, and we put the result is, and then we're going to display this variable here. So we're going to put a save, and we're going to build and run, and we're going to put a say, for example, 10 plus 40, and the result is 50. So how about we're going to do multiplication? So multiplication, you're going to put a star here. In computer programming, you can't put an x, because x is reserved for the letter x. You can't put an x, so programmer is looking for some ways to put these guys here. So you guys don't have like a with the normal math. We have a plus here, we have a minus. That's fine, but we don't have a say multiplication, because multiplication is reserved for x, and then we don't have say division, and divisions is with / our modulos here, say modulos with like percentage %, here. So now if you guys want to put a multiplication, we can do so. Control S to save, and we're going to build and run. Say if you put a 10 plus, if you put a 50, you're going to see it's 500. That's our multiplication. How about if you do say division? We can do division, and we can do division if you put a 9 and 3, for example, 9 and 3, you're going to put a 3 here. So that's how we're going to perform our arithmetic operation. We're going to create a simple calculator with the C++. So here I'm going to repeat again. We put some sort of number here. We're going to create some 2 variables here, and we declare x and we declare y. Both of them is the data type int. This is called type int. And now here, with the help of built-in C++ C in, we're not going to see out, we're going to put input. So we're going to take from the user for the x, and we're going to care for the y. So now we're going to create another variable here, z, our result, whatever you guys want to create, and we're going to assign here this guy is here on the right to this guy is here. So whatever the user is going to put here, x and y, and we're going to perform some sort of mathematical operations here, and we're going to assign to z. And in this guys here, we're going to just output to the user, so the user can see. This is the simplest algorithms inside the C++, and this is the basic computer mathematical operations, say, because the computers used to be calculators, and so this way we can see here we can create just some sort of variables here. We declare it, and we're gonna get some sort of value from the user, and then we're gonna perform some sort of operations here. So that's how the algorithms of this increment, decrement, and the algorithms of this calculator works. Let's talk about arrays. So we're gonna remove all those here, and we're gonna go a little bit up here. So we're gonna put arrays here. Arrays in C++. Keep in mind, arrays in C++. So first of all, we're gonna put some sort of data type, as we have done it before. So I'll put a comments here, arrays. So I'll put another comment here underneath. So with the arrays, make sure you guys remember with the brackets. So we have if we have a char, if we have array, and I'm gonna call it ARR arrays. So with the inside the bracket, you guys gonna put the size of the array. So we're gonna go inside here, and we're gonna put the size here inside. All right. So now keep in mind that the arrays starts from 0. From 0. So and goes say 1, then it goes to second element, then it goes to third element, and goes to fourth and 5, all the way to nth element. So keep in mind. So arrays, that's how you guys are going to put inside the size. Keep in mind it starts from 0. Alright, just like before, if you guys have a char, we can put a char a, for example. You don't need to put ARR, you can put a, just put the size here, and make sure you close it here. And if you guys want to have another data type int, you can put a, say for example, b, for example here, and you can put the size, say for example 5. You can just put the size 5 here. And to initialize your array, as I said before, say for example you have another int, for example you have x, or we can put ARR, and you have got a size 5 here. And how we're going to initialize our array? So you just put initialization here, put a bracket here, put a squiggly bracket here, and say for example you can put a 10, 20, 30, 40, 50, 20, 30, 40, and 50. Alright, so we're going to close this one. Keep in mind we're going to close this one. We have an array of 5 elements here. That's 0, 1, 2, 3, and 4th element. Keep in mind computer starts from 0. The computers don't start from 1. So C++ array starts from 0. So this initialization here, this guy is here. This brackets for open and brackets close here, initializes our array with the values in the list. So the first array element will be initialized with the value of say 10, and the second one elements will be initialized with the value of 20, and then followed by 30, 40, and 50. So now how we gonna display our array here? So inside here, say for example if I wanna display 0, I'm gonna put a C out here. I'm gonna put a std, scope resolution operator, C out, and then here you guys need to put that first element of our array. So if you guys want to know the first element of your array, which is say 10, you guys need to put a, say for example here, you guys need to put the name, which is ARR, short for we put an array. Keep in mind that this is a made up name. You can put A, B, C, X, Y, Z. You don't need to worry about ARR, but because just for simplicity, I just put an ARR and just put element here. Say for example, if you guys want to find out 0, you guys can do so by all means. You guys can put it this way. So Control S to save and build and run, and you guys going to see here that that's the 0. We have a 10 on the 0. As you guys can see here that the first element of our array is 10, because that's the 0th element, as I said before. So 0, 1, 2, 3, 4. So how about we're gonna copy this one, and we're gonna put a here another one stream insertion operator here. We put a next line, and we want to find out the last one, and the last one is array of say 4th here. Say we have a 0, 1, 2, 3, 4. So we're gonna put the last element of here is the number 4th one. So the last element, we're gonna put it the last element of the array, and now we're gonna display this one, the 51. So if you guys Control S to save, and if you look in here, we have our program says the first element is 10 and the last one is 50. How about if you put the wrong one here? So if you put a wrong one, C++ gonna give you error. Now if it's put it here, we're gonna run, and we're gonna see some sort of weird value here, because what happens inside the computer memory with the arrays, the computer, the C++ compiler reserve memory spot here. So you can think of this one as a pigeonhole, or you can put some sort of stuff that you guys gonna put here. Say for example, if you go in the library, if there is a spot for 5 books, you can put a 5 books there. If there's spot for 4 books, you can put a 4 books. So now inside the memory, we're gonna do exactly inside the computer chip, we reserve 5 elements here, which starts from 0. But if you do more than that, then you guys gonna get a say. How about if you have only 5 here, and we wanna assign the 15th one, because we don't have 15th one here, we have only 5 here. So if you guys gonna do that, then you guys gonna give the computer is gonna give up. It says, I don't know what you're talking about. It doesn't gonna make sense, because this one here, the size, it doesn't make sense for the computer. Alright, so how about if you guys want to change this one? Say for example, we can do so. We can change this one. Say for example, we put ARR of 0. We want to change it to say different our number. Say our number says 5. We can put a 5 here. So how about if you change the second one? So instead of 20, you guys can put a different one. So we put ARR. So ARR1, which is 20, we want to change it. So if, for example, we can make it something else. Say for example, we can make it 900, for example. So now we have changed 2, we have changed the 0, and we have changed 1. So we're going to remove the 1, and we're going to Control S to save, and we build and run. So if you look in here, the first one is a 5, we have changed it, and the second one is 900. So what happens inside the computer memory is the computer is going to come here and reads this one. So 5 elements, the first one is 10, and then the second one is 20. So later on it comes in again here, it reads line by line. It says, all right, this array is the name ARR. There is a 0th element here in the number is 5, the assigned number is 5. So quickly change to 5, and then this the first element here, and then that's the 0th element, that's the first element, and it checks here is 900 instead of 20, and then it overrides this one, the 21 inside the computer memory. Alright, so we're going to talk about the pointers. So I'll remove this one. I'm going to put a pointers. So what is pointers in C++? Pointers, sometime you guys are going to see here that we represent pointer with star. So as I said before, don't confuse this one with the arithmetic star, because that's multiplication, but this is totally different. With this one we can put it with integers, but this one you don't need to put it with integers, you just put it with the letters. What is pointers? Pointers are objects that reside in memory, and so far we have learned how to access and manipulate objects through variables. Another way to access our objects in memory is through pointers. Each object in memory occupies a certain amount of bytes and has a type and an address. This allows us to access the objects through a pointer. So pointers are types that can hold address of particular objects. For illustrative purposes only, we will declare it in initialize pointers that can point to our object. So if you're going to remove this all, so instead of we're still gonna put a say data type int, and we can put our pointer here with this one, and we put a. So now this is our pointer, and keep in mind, and just now you're gonna ask me, but Mr. Yazdani, this is just like a variable data type. Of course, this is a variable data type, but it's a type. We call this one as type as pointer, because you guys are going to see here with the int we put a star here. So now how we're going to read this one, we're going to say this one, this is a is a type int pointer. So that's what we're going to say this one. And another way is you guys can put another data type is char, and you guys can put your star here, and we can put a c, for example. So there, this one's is both pointers because they are pointing towards a memory. That's what we call this one pointer. So now here in top we have declared the pointer of the type int, and we name it a. So to make it point to an existing int object in memory, we use the address of operator, and how we going to call this address of operator, we just put end here. So this guy here, if this guy is a pointer, this is the address of operator. So we call this one address. Say for example you have an address in your street. If you are living number 10 ABC street, for example, then if I gonna come inside, if I want to refer to you as whatever your name is, then I'm gonna point towards your address, because that's the address you reside in the map, or in your town, or in your city. But that's exactly what computers are. Computers have address inside the memory. Say now if I want to put a, for example, change this one, if I put an int, for example x, and I'm going to put it, this one is 100, initialized with 100. So I'm going to put an int pointer p, and I'm going to put a, say for example, end x. So now here we have initialized 100 to this address. It means we have put this 100 to this slot, to this memory slot of x. And now here this guy p is pointing towards this address. So this is data type int of type pointer, we call it p, and this p is pointing towards the address of this x, which is 100. Similarly, if you have say for example char, how we're gonna put a char c, and for example we put a q inside, and now if you guys want to point towards this one, you just gonna put it here, your pointer here. So we put a char star, just put a star with it, and we're gonna put a say cp character pointer, and we're gonna put a, if you guys want to point towards this one, you just put an end, and we just put this guy here, we just put this guy here c. So keep in mind, you cannot put this guy here and this guy here same name. So if there's a character c, we name it c, or xyz abc, whatever you guys want to put it, we initialize with q, because we are reserving some slots inside the memory, and this guy here is pointing towards the c. So how do we know pointing? The first part is that we have got a character pointer, and we name it cp, and this assignment operator, it means this guy is here from the right going to be assigned to this one. So now this cp has the error of c. If you have a friend, think of this one yourself, and whatever your name is, and you have a friend, and that friend now has your address. So cp has the address of this c inside the memory of computer. And the last one but not least is a character null pointer. So you guys can have a, for example, character, and we're gonna put our star here, say x, or you can put a z, whatever you guys want to put it, and we're gonna assign this one as a null pointer. nullptr. So that's called null pointer. It means there is no value inside this p. So that's what now this one is a null pointer, this z. So pointers are variables, or you can say objects, just like any other types of object. This their value is the address of an object. So that's what is specifically the pointers are. That's for the purpose. So now if you have a variable here x, and this x have the value x is somewhere inside the memory, but this pointer is just like a variable, or you can say object. So what's the job of this pointer is to get the address of these guys here. And how you gonna get this one to this address? Just press the A here at the front. Just press this n% at the front. So once you put this one now has have the address of this variable here x. So as I said before, their value is the address of an object, a memory location where the object is stored. So to access a value stored in an object pointed to by a pointer, we need to dereference a pointer. And this guy here is called dereferencing operator here. This guy here. First, you guys need to point towards a memory location, whatever, towards a variable with your pointer. So in order to access a value stored in an object pointed to by a pointer, we need to dereference a pointer. So dereferencing is done by prepending a pointer variable name with the dereferencing operator, which is this guy here. We have now have a pointer p, which is pointing towards x, and now we have another one, pointer cp, and then this one is pointing towards the address of this c. Alright, so as I said before, now the only way you guys can dereference this one is that you guys can put an int. So whatever name you guys gonna put it, say for example we don't have a b, we put a b, and you guys need to put a star, and you need to put this p. So now you have star, and then you put a p. So now you have effectively dereferenced this guy here. So this guy is dereferenced here, and similarly here we have a character and then we assign q, initialize it with q. Underneath we have a character pointer, and we call it cp, and we have end x and c. So how about if you guys want to dereference this guy here, cp, you just put a character of the same data type. Keep in mind pointers must be the same data type, and you can call it say we have a b, or we can call it d, for example. So d, and you guys, if you guys want to dereference this one, you guys put your star here and just put a cp, the name where this cp is coming from. This guy is here is cp. So I made a mistake here, not a co, but it's a cp. So if you're gonna see, if I comment out this guy here, say underneath that if you, the first ones we're gonna see the first pointer, result is, alright, so now we're gonna comment this one as well. So now if you look in here, we have a variable which we assign 100. It means it has a somewhere inside the memory this 100 value is stored. Now we have int pointer, and we call it p, and we're going to access this one. So now you guys are going to come here, and here we're going to put our pointer here. So what we're going to put it here, we're going to put this guy is here, the p. So if you look in here, we have got the address of this one here. The first pointer result points to this guys here. This is the memory address of this x here. And similarly, you can do the underneath one. Just put a double forward slash with to comment it, because we want to find out the cp. So here we're going to put a cp, for example. cp, the pointer is pointing to the memory address. Alright, so the pointer is pointing to the memory address, and is CP. And if you guys want to put a next line, you can do so by all means. Just put a backslash and put an end for the next line, and Control S to save. We're going to run it, as that's what you guys are going to see here. The pointer is pointing to memory QD. So that's what the QD is. So now if we want to have here another one here, we're gonna put it here. We put a double, say for example, if you guys want to put a money, name it money, and you guys need to put some sort of 500 here, or you can do 500.70 because that's a double. And you guys put another double, we put a double, and you can put a clerk for example, and then we gonna put it here, star here, because we want to make it pointer here. So that's a pointer now, and then now we're gonna put here the address of this money. We put an end, and then we put a money here. So if you guys want to access this guy here, we can do so. Just copy this one to make it a lot easier. So because we are feeling a bit lazy, so the pointing is pointing to the memory address. I was pointing to the pointing to, you can put a 2 here to make it short, 2, and then here you can put this clerk here. So just put a clerk. So now we have some sort of the third line here. If you want to put a next line here, just you can do so. You just put a backslash next line and copy and just save, and then we're gonna put it here. So looks like we got a spelling mistake here, because it's a clerk, CLERK, we put a C here. So we're gonna build and run, and if you look in here, that's the first memory address. That's a QD for the char, and the char is not showing the memory address. And the last one, the pointer is pointing to, that's a memory address for the last one. This guy here, money, this 500.70 is stored somewhere inside the memory. In order to find out the memory location, you guys can do this method here. So you guys just put some sort of double, and which we put a pointer, we name it clerk, and we are putting this ampersand at the front, and we are just pointing towards this memory address. So as soon as you guys can put it now inside the memory, you can see easily where this 500.70 is stored. This stores this memory address because we work it out here underneath. Alright, so we have seen that how we're going to see the location of these pointers in memory. So now we declare our variable here. We're going to put the pointer here, and now we're going to see the location. We have seen the location of all of these. So how about if we look at the actual value? So now we're going to talk about the dereference pointer. So I'm gonna, if you guys want, I'm gonna put it here as a dereference pointer, so you guys remember. Okay, so how to do the dereference pointer? So I'm gonna remove all this, and I'm gonna remove this one as well, where we can actually leave one. Alright, so now we have say for example we have a character instead of int. We have char, because char is only one character, and we name it C, and you guys can put XYZ or ABC, whatever you guys want to put it. Say in my case I'm going to put a Z. So now I want to build a pointer, as we said in previous video, that pointers are variable or objects, just like any other type of object. So their value is the address of an object, a memory location where the object is stored. To access a value, and as we said before, to access a value stored in an object point to by pointer, we need to dereference a pointer. So now how we're going to dereference, as I said before, now we have a character here, we name it C, and we put a value of Z. Keep in mind that's not a string, because strings is array of characters, too many of this is string. So now we're gonna put it another character here, pointer. So we're gonna put a character pointer here, and we put it, say for example P, and what we're gonna do in we put a reference of this C here. So now it has a reference of this C. So how about we're gonna dereference that one? So what we're gonna do is that we put a C out, and we're gonna use this guy here instead of typing once more. We're gonna put it here. So the first pointer, we put at the value of dereference. So the value of pointer is, and here we're gonna put a P. So we want to see the P here with the value of this character pointer here, and this is before the dereference. Now keep in mind, whatever we are looking for the result, this is before the dereference pointer, and that's the location of this pointer, and the value of pointer is before. So I'm going to put it here before, and I'm going to copy this again, put it underneath here, and I'm going to put it after. So the value of D, so I'm missing E here, the reference pointer is before, but now we're going to put it after. And what you guys need to do, as you guys see here, we have a pointer in front of char, we can put it here. So now you're going to see the actual value, which is Z. Whatever value you guys going to put it here. So if you put an int 100, you're going to see 100. You're going to see the actual value. So if you guys put a star here in front of this pointer here, you're going to dereference it again. So now we have we're going to put this pointer now pointing toward this C, and that's the reference. Now we're going to put it here as a dereference here. So we're going to build and run our program. So that's how we're going to see the value of pointer. Is that the first one is the location, as you guys going to see here. Here we put the Z. We're going to assign this one to the C, which is a character. Here now we are looking for the value, looking for the location, because we are referencing this location of this variable here. And now the second one, as you're going to see here, now we're dereferencing now we are dereferencing the pointer, and now we're going to see the actual value, which is C. Now if you guys are here looking here, that's before the dereference and that's after dereference. So now we're going to make it a little bit more complicated. So now we're going to put a, say for example, int. We have a X, and we put a 400 for example. Now we declare another pointer, and we put a XY, and we're gonna go to the reference to location of this X. Okay, so now if I have put it here, so the first one is gonna be, say Y, and then now we're gonna put a Y again. So now I have dereferenced this one. So now here is both of them have a Y. Alright, so now we have put a X, which is the variable. We assign 400, which has a memory location. Here we declare a pointer. We put a Y, now this pointing towards the location of this one. Now we have put a reference to this X, and now here we dereference this one. So if I now if you're looking here, the first one is the referencing location, and the second one is the actual value, which is 400. So how about I'll do a little bit changes, and instead of putting this Y here, I'm going to put it here. So I'm going to put this Y dereference pointer, and I'm going to put a value of say for example, I'm going to put a value of 900 or 999. So, and now I'm going to remove this one, this guy here. So as we know, that the value of this one's because now here this is the reference, we're going to see 999. Okay, how about I'm going to put say the actual value, which is x. So now you guys tell me, if I put an x here, are you guys going to see the 400 or are you going to see the 999? So we're going to try this one. So now I'm going to put out, say for example, x here. So and I'm going to put the value of say x is, and I'm going to remove this one as well, and you guys going to see this one. I'm going to build and run. So and you're going to see that 999. What just happened here? If you look in here, the value of x is 400. So now what happened here, because we have a variable here, we put the name x, we assign 400 value. Now this has a location. Here we are declaring a pointer here, we name it y. Now we are referencing to the location of this variable, which is x. So here now we dereferencing this one, this y again. Here we are assigning our own value. So now this x becomes have the value of this y. It sounds a little bit confusing. Now you're going to guys telling me how this x, which have a value of 400 with its own address and everything, it becomes a 999. That's the beauty of C++. So now you guys looking here, we have I'm going to repeat again. I have declared a variable here 400. I have assigned 400 here. Now I have put a pointer here. I'm putting reference to this x, to this pointer. Now this pointer y is pointing towards the location of this x, and now I have dereferenced this one here, guy here. I have assigned my own value, which is 999, and you guys going to see here now this x is changed. So you can see here the x is now 999, which is the new value. Alright, so now we're going to talk about the references. Now if you guys remove this asterisk here and put an ampersand here and remove this guy from here, what happens now, this becomes reference. So now his pointer is quite the opposite of reference. A reference type is an alias to an existing object in memory. References must be initialized. So how we gonna initialize this guy here? And you're going to see here, instead of putting pointer here, asterisk, we just put an ampersand sign here. So now what happens here, instead of referring to the location of this memory, now we're going to referring to this the value here. Say for example in memory, which I said before, this like a boxes. Now this 400 have a special box and address. Instead of we refer to the address as before with the pointer, now we're going to refer this x is going to have a value of 400. So now this y is also going to have the same value of this 400. So we're going to remove this x from here, and we're going to put the value of you can say the x or y. I'm going to put the y is control S to save, and we're going to run, and the value is 400. Even though as I said before, it doesn't matter, you guys going to put x and y, it's going to have the same value. So if you guys going to remove this x, control S to save, and we're going to see that the value is going to be 400 regardless of what you guys going to put x or y. It's going to be 400. So how about if you're going to come here and say for example put a new value to this x. For example, x is going to be 800, for example. Can we do that? We're going to find out. Now we're going to put a y here because the x is resides here. Now the y is here. So what happens in the memory, now this x had a 400, now the value changed to 800. So as the value changed 100 for this x, the y's value also changed. So if you guys don't believe me, we're going to run and we're going to see the value of 800. How about we're going to change the value of y, for example, instead of x. Now we know that this whenever we change the value of this x, the value of y changes too. So we're going to put y is equal to, for example, 9,000. So now even though we're going to put a value of y, what happens here, if you guys check if the value of x change or value of y change, now we're going to see the value of y is changed in the memory to 9,000. So this is called reference. It's called a reference, so I'm gonna not a dereference, but we're gonna put a references. All right, so now that we know about the references, another concept in C++ is called const reference. So what is this const? Const in computer memory, as we guys have seen here, that whenever we change the value of this x, the value of this x change, and whenever value we change the value of y, the value of y is changed as well. So as we said before, that another concept in C++ is a const reference, which you guys going to see a lot in C++. So const is a read-only alias to some object. So now instead of we put a reference in front of this int, we're gonna just add the const. So now this y is become a constant. So why we use const? So for example, now as we have seen that previously that this y was changing, so in order for us to tell the C++ do not change the value of y, we have to use the const. So if you guys gonna run this one as a const, you're gonna see here that the value is a 400. We're going to talk about the references and const references in more details when we learn about the function and function parameters. For now, we assume that they are just aliases or just references. So a different for example, in some cases, additional name we give to our existing object. And then one more thing that you guys remember that is important, not to confuse the use of asterisk in a pointer type declaration, such as we put this one int pointer p, and the use of star when dereferencing a pointer such as p, such as asterisk, and then we put a p previously. For example, whatever the value you guys give, for example, 456 or 100. All right, so now we're gonna remove this, and we're gonna put some double here. So I'm gonna remove this as well, and I'm gonna put this view to full view, so we're not gonna get distracted. I'm gonna put a full view. All right, so now here we have the value of y. We're gonna leave that as it is. We're gonna put some doubles. So we put a double, for example, and we put a double, for example, x, and we're gonna put this one as a 400 like before. And now we're gonna put a double, and this is a reference, and we put a say double ref, for example, because we want to identify this one as a double. So this double x and double ref, we have another one double ref, which references this guy here, double x. So for example, now we're going to put a double x, for example. Double ref in is referencing this double x here. So in memory, this double x has a value of 400. Now here the second one, double ref, is also have the value of say this 400. So now we're gonna check the double for example ref here. So here the double ref here, the value of references is, because we're gonna add another one. Okay, so now we're gonna Control S to save, and as you guys gonna see here that is a 400. So how about we change this double ref the value? So if you're gonna put a double ref, and we put the value of say 700.90. Okay, so as because it's a double, you guys can put a point here, say for example 0.8. You guys, it's up to you guys want to do that or not want to do that. So now we're gonna check the reference, and here is, did you guys see this one, the value changed to 700.9 because here we changed this double ref. So here double ref, our we can put double x here. We're gonna put a Control X to copy. So here we're gonna check this guy here, and we're gonna check put this one here, and we put a the value of original, and we're gonna put here then references. Okay, so now this is referring to this double X, and now we're going to see the check the value. I look like I have the typos here. So now we have we're going to check the value of double X, and we're going to check the references for this double X, and you're going to see here the first one is 700.9 and this one is 700.9. What just happened here, this when we change here the value of this double, this one changed as well, as you guys going to see here in this one, that this guy has been changed and this one changed as well. Why is that? Because now, as you guys seen here, both of them was referring to 400, and here this double ref was also referring to this one. Now the both of them change to this one. So how about we're gonna copy this one, the entire one here, and here I'm gonna copy that one, and I'm gonna change again. So here I'm gonna put a double X. I'm going to change the value. Say for example, I'm gonna, so we put a 400, 700. I'm going to put a say I'm going to put a say 20, for example, 20.10. So now we're going to see if the value going to change, because initially we put this one as 400 and both of them was referring to this 400, and then we're going to change the value of this 700.90, and both of this double X and double ref was referring to this one. So now here we're going to change the original value of this one to 20.10. Now we're going to see if this double X and double ref reference ones is going to change, is going to look for the same, is going to reference the same value, so 20.10. So we just hit the Control S to save, and we're going to build and run our program, and we're going to see here that the first one, and here this guy here, we have originally we had a 400, and both of this was double X and double ref was referring to this one. Now we change this one to double ref 700. You're going to see this one that the first one was referring to this 700.9. Both of them is double X, and you're going to see double ref. Now here we changed the last one, we changed to double X 20.10, and now you look in here, this double X and double ref is looking for the same value, which is 20.10. Why is that? Is because we are changed the reference. This is called reference, and as we said before, const reference. So we're going to go through this references and const references. As before, const means you cannot change the value. As you guys seen here that we are changing the value of this one. So as we originally, as I said before, that we put this one 400.8, this two referring to this value, then we change this one to the 700, then this value and this value was this our double X was referring to the value of 700.9, and this guy as well, because originally this guy has changed the value. In the second instance here we have or you can say the third one, we have changed it to 20.10, as we've seen here that both of this data type double X and double ref was referring to this one. So this is references and const references. Alright, so now we're gonna change the layout a little bit. So I'm gonna go, because I was trying to magnify this one, I'm gonna go a little bit, say I put it on full screen so you guys don't get distracted, and I'm gonna go on special commands here on edit. It says special commands. I put just a little bit zoom so you guys can see clearly. I'm gonna put a little bit here so you guys can see clearly. So I'm gonna put a little bit out, so special commands. It's up to you guys. Don't need to do that, because I thought maybe I do this so you guys can see it clearly, because as we progress we have to make, I just trying to make it visible for you guys to see. Alright, so now we're going to talk about the strings. Here I'm going to change this one, and now we're going to put it on strings, our you can say literal strings. What's a string? So if we can remove all these from here, I'm going to remove this, and I'm going to remove these guys here as well, And as you guys know that previously we have used hello world, and you guys see here this is a string. Whatever you guys gonna put this in between this two double quotation is called literal string. So as you guys remember, initially we put a hello world. This is a literal strings. Why we call it strings? Because initially when the computers were invented, we had something called char, and this char is contains is just one word. So either A, our either B, our C, D, only one. And then it's a big headache for the programmers, because you can't just spend all day, our week, or month to just put something here on the screen. Why? So why not create something that holds a lot of characters here instead of just one? You cannot just embed one at a time, and it's going to take you guys ages to just write this hello world. So how many chars takes for you guys to just put this one here and display it on the screen? It's going to take you guys hours. So just a hello world is going to take you at least 10-15 minutes. So why not just invent something that we can put just one thing on is one line, our sentence, our whatever paragraph on the screen. So they invented the strings, and strings very important. String. And you guys gonna see here we have a stream. Stream is totally different stuff, but you guys gonna see here is stream here. We can string stream is like we can store string literals inside this string type. So the C++ standard library offers a compound type called string, or rather we can call std string. So as it is part of the std namespace, so we can use it for storing and manipulating strings. And some people, some programmers, they gonna put this one as they include this one as a string. Sometimes you guys needs to put this one as a string. In some IDEs you guys have to include this one, but because we are using this code blocks, and the code blocks have something at the back which even if you guys don't use it, still you guys going to see this string on the console, or you can see on your application. But in some programmers, they use this one as you have to declare this one here on top. So and then when you guys use this string, say for example if I put a string here, say instead of this hello world, I'm gonna put a say hello, and I'm gonna put a hello world here. So I'm gonna put a hello world. Alright, so now I don't need to display this one. I just put the reference. I'm gonna just put the name here, because this hello got this string. So now here, so I'm just gonna put a hello. And as I said before, that the strings, they are in C++ standard library, so you guys need to put this std with this one. So if you guys don't put this std, C++ gonna be extremely angry. So if I put a Control S, if I try to run my program, then you're gonna see here that C++ is mad. It says why you put this string here, and why you put this guy here without this standard library. So if I try to run again, my program won't even start. So if I look at here, string was not declared in this scope. So when you have an error, it says the string was not declared in this scope. Did you mean std and this scope resolution operator, the two columns on top of each other? You guys going to see here the column 1 and column 2. This is what we call the scope resolution operator. And if you guys wanna, so if you guys don't want to get error, our string was not declared, cout was not declared, hello was not declared, you guys gonna see here build failed. So it means that you guys did not use this std. So if you guys put a std, means standard template library. So now you guys gonna see our error has gone, and you guys need to put here this guy's here. Why you guys gonna put this one? Because they are part of the C++ standard library. Because you guys, there is somewhere in C++ programming, the core programming, this string was defined somewhere, That's what we are declaring this string here, and this I stream here. So if we build our program and run, and you're going to see here we have no error, and we're going to see here hello world. You can put your name if you want. You can put a hello. You can just put your name, and I'm going to put my name is Yazdani. Whatever you guys string you guys going to put it here, it's going to display. You can put your country name. You're going to see here, even though I put here exclamation mark, or you can put a 2 colon here, it's going to display, because they are all part of this string. So with the character you can use only one, but with the string you can use the stream like a array of characters. That's what we call the strings, or arrays, or you can put arrays of characters. Array means a lot of them, means a whole bunch of them. Our you can see here one after another consecutively use the strings. Our character, we call this one a string. Alright, now we're going to see how we're going to concatenate our string. So we have a string here, we have a variable here which is the type of string, and I'm going to remove this one here. Say for example, if you guys have hello, and you want to put your name, or you guys, if you want to add something here, or you want to add another literal string here. So the first one is, as we're going to see this, we can do the literal string to our string using the compound operator. So what is a compound operator? Compound operator is a plus equal to, this is called compound operator. This is equals to, say if you guys want to add something to, say a number or numerical, or say string here. So how are we going to do that? So here we can use the variable here. Say we have a variable of hello, and we put a plus, we put an equal to, and we can put our own string. Say for example, you can put a hello YouTube, for example, or hello, we can say programmers, YouTube, say programmers. All right, so now we're gonna close this one here. Now what we've done here, we use the variable here, the type string, and we have added these guys here on top. So what we're going to see here, if we put a control S, and then if we build and run, and we're going to see our hello YouTube programmers. So we can add plus equals to, this is called compound operators. We can add this to our variable. The first one is, you guys need to use your variable. Say we can do this any letter you guys like. You can put a S, or you can put a H, X, Y, Z, whatever you guys like. You can put your own name. So as long as you guys put something here, the C++ is going to be okay, because we're going to add another literal string here on top of these guys here. And if you guys use this guys here plus, we use it in our numeric. Say we can put a 1 plus 1, but we can use it in with the strings as well. You guys can concatenate two strings. What's concatenation? Concatenation is like joining. So I'm gonna put a so you can say concatenation or concatenate. It means it's joining the two strings together. For example, now we have put the same ones. We can create another variable here. Say for example, hello, or we can put a say here YouTube, for example, YouTube. So we're gonna put a std. Don't forget this guys here, scope resolution operator, and you put a string here. So now what happens here? Now we have two strings here. When you guys get to advanced level, you guys gonna find this one very, very useful, because you guys gonna have declare a lot of strings in different classes, and then you guys wanted to join this one. You can put here plus here, or you can add another strings. So what I found the easiest one is that we can put a std. We can declare another string. Say we can put a result equal to, say we can put a hello here, the first variable hello, plus you can put a YouTube here, YouTube. All right, so now what happens that we have used this variable here hello plus YouTube, because we are joining this together. Now in the computer memory, these guys have the result for the both. So now if you guys want to see that on the screen, you guys need to put a result here. That's it. So Control S to save, build and run, and we're gonna see hello YouTube programmers. So this is how we're gonna do the concatenation in C++. So internally the type is we have used this std, and string is the so-called class template. It is implemented using templates, so which we can, and we're going to discuss this one in later on. And keep in mind that's how we join the two strings. You can create as many strings as you guys like. You can create the third one as one, so you can put this one S1, our S2, our this one S3, and you can see, if you want to see your result, you can put a S3 here. You can put anything you guys like. So as long as you guys gonna put here the plus, which joins the two string, you guys should be good to go. All right, so now with the strings, keep in mind that we can access these individual characters here. As we said in previously that before the C++ invented, there was a C, and this C had characters, and with C++ came in, they solved this character issue once and for all. So what I mean by that one is that now if you guys observe here, we have a string here, hello, and it has a lot of characters here. So the first one is H, and then ELLO. Keep in mind C++ reads it as from the 0. These are our elements here, and we can call it index, and the index starts from 0. And how we're going to access our characters, so individual characters of a string, we can access it through the subscript operator. So we put a subscript operator, and this subscript operator is just like here. And keep in mind there is another one here at the C++, and it's called at. What's inside here we can access, because this is a inbuilt inside the C++. So once you guys go in professional programming in C++, you guys will find out that what I mean is that how we're going to access these individual characters. Say for example, now if you guys, how we're going to see there is a H here. Now because it's a string of this all literal string in here, a lot of characters here. So what we're gonna do is here, then now we're gonna put a char. For example, we call it A1, for example, and what we're gonna put here, hello. This because the name of this our string is hello, so we put a hello here, and we put a 0. So we put a 0 here, and what we're gonna put it here, we're gonna put the first element is our instead of elements, we can see the first character is. So you guys put it different here, and what we're gonna put it here as A1 if you guys want to view your first one. And keep in mind we put a 0 here. If you guys getting confused, we can remove this guy here, H, and we can just leave it H here. So now this H is this guy here, the first element, or the first character. So the first character of this one is H, as you guys looking here. So how about we gonna copy this guy here again, and we're gonna paste it back here, char, but don't put it as A1, you can put it as A2 for example. And here, because you guys need to put a different variable here, so what's the element you guys want to look? So 0, 1, 2 for example, if you guys want to check the second one. And if you guys want to copy the whole thing here, or you can put it your own, and the second character is here, you guys need to put a A2 here. So the second one is second char is, we just call it char instead of characters. So here we're gonna build and run, and now you're gonna see here that this one's gonna be L, because this one's a 0 and this first and the second. And if you guys we're gonna count it as 0 1 2 3 4. So we're gonna put a char, we put a A3, we call it A3, and as I said before, we put a H, we put a at, and then you guys can nominate your whatever you guys looking for. So if this was 0 1 2 3 and number fourth one, so if you guys want to look at the fourth one, and we're going to copy this guy here, instead of writing we just copy paste it to make the process a bit quicker. So here, and we put a next line here. So the fourth character is, and don't put it as A1 because you guys need to put an A3 here. So A3 is here, Control and S to save, and build and run here. And you guys are going to look in here, the last one is going to be O. So the first one is H, then we have a L, then we have O here. And that's how you guys access your characters here. So keep in mind with C++, you guys need to, if you guys want to access it, you guys are going to put a subscript operator. It's just like array here, and there is inbuilt function, we call it alt. And here it doesn't matter if it's hello world or is hello YouTube or hello whatever here, hello universe, whatever here. All you guys needs to do here is just you guys needs to put some sort of array here, or you can say indices here if you guys want to access these elements in C++. So that's how you guys going to put an individual one. Keep in mind there all of them's strings are arrays of here, instead of if, that's of characters. So initially it was called char in C, and C++ came in with another class called string to solve this problem. So instead of writing each one by one, which takes a long time, C++ came in with a literal string and solved this problem once and for all. Here that's element 0 with the array, and that's a second element, and that's the fourth one. So the first one we can do with this one, or you guys can, it's up to you, you guys want to do with this one, whichever is easier for you guys. Now that we know how to look at our indices here from with the array, now it's time for us to see how we're gonna get, instead of this hello, we should get it from the user. So I'm gonna delete this line here. We need this line, and we're gonna modify that later on. Say I'm gonna remove all this, instead of say how we gonna get the user input of a string. Say for example, we're gonna put it here, user input. As you guys see here, see out, it means it's gonna go out of the console, on the console, and then C in opposite. This one is that how we're going to get it from the user. And the best way is to accepting the string from the standard input is via say we put a get line function, and the get line also gets takes a C in as a string parameter. So what do I mean by that? Say we put a string and then we put this string, our string H. You can put a S, you can put a X, Y, Z, or I'm going to change this one, say for example to X, because we don't know what strings the user is going to put it here. So now we're going to put the C out, and you guys can take this C out here, just remove all this, and then here is you can put a please enter a string. So please enter a string, say for example what the user is gonna put it here. So here underneath you guys need to put a std, and then we put a get line get, and I'm gonna go a little bit here so you guys can see. You put a get, and then you're gonna put a line ling, and this is inbuilt C++ function which gets everything from the user. So we put std in, and we put a c in, and then you guys need to put this x here beside it, because it takes 2 parameter here. So you guys need to put an x, and then you guys can display your whatever string here. So here you guys can copy that, and we're gonna paste it here to display on the console. And we're gonna put it, you entered what we entered here, and then you guys need to put this x here. So I'm gonna put this x here, and if you guys want this one to display, you can put an x, whatever the here we can we have declared. So we have declared the string x, and then here we just displaying to the user to put something here, and here we're gonna put a get line, and then the first one is going to be c in, because we're going to get the value, and then we're going to store the value to this x here. So this one makes your code very clean and concise. So we hit Control S to save, and we can build and run. So what we're going to put here is string, and I'm going to put Yazdani. You can put your own name, and then you entered Yazdani. That's how we're going to get with the help of get line. This guy is here. We're going to get it from the user. We can just put a std c in here as well, instead of c out. So but that's another way. So if I put it like that, so what I'm gonna do here, I'm gonna put a std c in, and look at here, this guy is here that we're gonna put an output from the on the screen. There it says that output, but now it says input here. So the c in with all these arrows moving towards this this guy here, x. So we can put it this way as well, we can put it this way as well. So whichever you guys think is best, you guys can do that. So that's but this is more clean coding. So we can build and run, and you guys gonna see that it says that enter a string. I'm gonna put again, say for example YouTube, for example, and it says you enter YouTube. Same thing, no problem. It's up to you. I leave it up to you guys if you guys like this way, or if you guys like this way. It's up to you. Alright, so now we have tried the first one, and we have tried the second one. As I said before, it's up to you, but this is more clean coding, and this is more popular. Why is that popular? Okay, so now, as I said, type before Yazdani. Now I'm gonna type again. So you guys gonna look here. Some users might put this way. Say they might put it here. There is space in between. So looking here inside the memory, the C++ C in only cached this bit, but didn't cache the DANI. While the get line 1 here, so this guy here, if we activate this guy here, Control S to save, if we run it here, and look at here, I'm gonna put a yes, I'm gonna space, I'm gonna put a Danny, and I'm gonna put a space, and for example, I'm gonna put a Trump, and I'm gonna put a space, and I'm gonna put a Biden. And you look in here, instead of just one, it says that you entered YAZ, DANI, Trump, and Biden, all these strings here. So it doesn't matter how many times the users put this one here, the white space here, instead of say just one, the one string or two string or three string consecutive. So so in short, C++ here the C in, this guy here only caches the first one, consecutive one, but as soon as you guys put the space, it's not going to cache. While the get line caches everything, whatever the users put it, even if the users put 500 lines here, and the cin, the get line is going to cache that. So we use the get line because our string can contain white spaces, as I said before, that the users might put some white spaces with their names. But if you put a cin in your program, that cin is only going to cache the first whatever the consecutive characters are in whatever the users going to put it there. So the cin is going to cache whatever user is going to put the first consecutive characters, be it say 3 characters or 10 characters. But as soon as the user is going to put the white the space, then it's not going to cache. So that is the problem with the cin while compared to the get line. So that's what I said, the get line is more sophisticated and more popular. Okay, so now we're going to talk about the pointer to a string. So a string has a member function, just like here, get line. As I said before, that the string has a member function, cstr. str stands for say string, say it has a c str. So you guys need to know. So what this function, just like here that we have explained, that's very good. If you guys do this one, cstr is also inbuilt C++ function, which returns a pointer to its first element. Keep in mind, we have a pointer to a string, or we have a pointer to a substring. So it also returns a pointer to a null terminated character array our string is made of. So for example, now we have a string x, and we're gonna put a, you guys like to put anything you guys like, say put a hello YouTube, for example, hello YouTube. Now this is a string that holds all the value here inside the x. So how we gonna point towards this string with the help of cstr. So in here we gonna put this one as cout. We put a pointer to a string is, and here you guys just whatever leave the x here and just put a cstr. So we put a c underscore str. If you guys notice here, we didn't do anything, we didn't put anything on top, we have done nothing. So now here we put a hello, that's our string, and here we have a YouTube, and now we're gonna see if we press the Control S to save, and we run our program, and you're gonna see here that's we're gonna see our string on the console. So if you look at here, we have a pointer string which is the hello YouTube. So this cstr is a member function of the type const character, const char. So we can put it here. It's a member function of const char pointer, and it's useful when we want to pass our string variable to a function accepting a const char parameter. And keep in mind that we have a cstr, which is as I explained to you guys here about the const character string. We have also substring, so sub str, which is also inbuilt C++ function, member function, to create a substring from a string. So the function returns a substring that starts at a certain positions in the main string and is a certain length. And the substring is we have a starting position and in the length. So here we put a hello YouTube here. So how we gonna do the substring here? So here underneath you guys needs to put a std, and we put a string, and here you guys gonna put a x, say y substring, and here you guys needs to put a x dot sub str. So sub, and what you guys looking here for the starting position of this one, we're gonna put as say 0 1 2 3 4 5 6. So we put a 6 here, and the length of this one, whatever length you guys want, you guys like, say for example this one has a 6 length, so we put a 6 length here, and here we put this our substring. So we put this guy here, s substring here, so we put a sub str. So here we put a y substring. So this guy here, Control S to save. So now we have started from this guy here, and we just want to view 6 character here. We don't want to view anything more or anything less, but we just want to view 6. So Control S to save, and we're gonna build and run, and you guys gonna look here, the 6th one is gave us this guy here, but not the E at the end of YouTube. So if you guys want to make this one 7, Control S to save, and we're gonna now watch that the whole YouTube's gonna come because 7 characters here. So this is the substring. You can use this one as you can put your full name. It's very useful when you guys go in real world programming, and you guys need to look at the character, say for example in search engine or something like that. If you guys want to look at the substring, say for example in 1000 word or something, then you're gonna want to, if you want to find exactly the same matching substring, then this one is very, very useful because it points, as we said before, towards this strings. Alright, so now I'm going to remove this one here, and we're going to talk about the automatic auto type deduction. So I'm going to put an automatic type deduction. What is automatic type deduction in C++? As I said before, that if you guys want to say for the char C, you guys can put an X for example, but you're gonna come from time to time, you guys are sick of this char. Instead of every time you guys gonna put it, so you don't want to put it, so you can, C++ allows you guys to put auto. Auto means after that you don't care. So we can automatically deduce the type of an object using the auto specifier. Here, whatever the initializer here, we can instead of putting char or string or int or double, whatever you guys, our float, whatever you guys think of, instead of that one, you just put say auto. C, or you can put auto x equal to 100. So now I don't have to worry that about the int. Here I don't have to worry about the character. And underneath here you guys can put an auto, say for example y equal to say 700.70. now I put a double, so now I don't have to worry anything about these things. So all I need to do is just put auto. Auto is very, very easy. The first part of this guy here, automatic, it means auto, and this one's very, very useful. So keep in mind that the auto specifier deduces the type of an object based on the object's initializer type. This is initializer here. You can even use it with say reference types. So we can put an auto, and you guys need to put an end. We can put a Z, and we're going to reference this one towards the X, or you can put it whatever you guys like. You guys want to put it towards, for example, Y, we can reference that one. So now this Z is effectively becomes like a double here, because this Z is now referencing this Y, and it's effectively becomes a double because this Y is double. So I'm going to put it here, double, and this Y is reference to this double. Whatever, if you guys want to put it towards a string, this auto, or towards this character, it becomes a character. If you are say putting reference this Y towards this C, it becomes say char, or you can say car. So it's not a double anymore. So now think of this one's very, very easy. You guys don't need to worry about putting int or double or integer or character, string, whatever. You guys need not to worry. Even with the references, you guys don't have to worry. Just put an auto and put an end at the front. So what about constant? We can put it with constant as well. So we put a const. As I said before, constant is something, say for example a, we put a const, we put an auto, for example a, and we can put a type of say for example integer. So now this is a const integer, or here we can change it to age. So if you're making program, that you don't want to change this age of the user, our date of birth, say for example DOB, then you guys put a const, then you put auto. Very useful. So whatever the user is going to put in the profile, the program for the lifetime of, as long as that program is going to be alive, no one can change this, whatever the date of birth, say for example 19, say for example 19, if the user's date of birth is 1990, the year, then there is for the entire lifetime of the program, no one can change this one, because now it becomes a constant. And you guys don't need to worry about putting int. You guys don't worry about the putting int, because you already put auto here. So as soon as you guys gonna put auto, C++ automatically look at this one and says, what is this? This is int. So C++ in the memory gonna allocate for you guys space for the int instead of for anything else. Say for example, if you put a double, then the C++ gonna put a double. If you put a character, then the C++ gonna put a character. If you put anything you guys gonna put it, the C++ gonna go automatically, the initializer of this one here automatically assign this one here. Alright, so if you guys want to put a cout, we can do so. If you guys need to put a std cout, and here we're gonna put it for the first one is gonna be C, for example C, and then here next line, and then we put the type C is char. So that's how we're gonna put it here. If you guys gonna want to copy this guy here to make it a bit quicker, we can copy again, and we're gonna copy again here. So now here is the type of x. So the type of x is int, for example x is int. We're gonna put an int, and don't put it C, because C for character, X for int, X for int, and Y is for double. So Y is for double, X, Y is for double. Our you can say float. Alright, so we built and run our program. The type C is a character, which we put it X here. So if you look in the X here, don't confuse this X, because it's just a character. This is different, this is later. So here the X is 100 and the Y is 700.70. So if you guys want, you can change this one to say for example D, anything you guys like. So if you run our program, you're not going to see X, you're going to see D here, and you're going to look here with the automatic type deduction. We have solved all this initialization here. So instead of putting int our character, our string, whatever, our double, float, whatever, we just put auto, so we don't have to worry about anything else in our program. So this one makes it like a shorthand. It makes your program very quick and very effective. Alright, so the next one we're going to learn is the statements. So we put a statements here. What is the statements in C++? So far is that we have learned how to declare our data type here, how we put a name, how we assign some values, our data type, our say variable here. So this variable have the type char, this ones have an int, and this ones have a double. But the programming so far, so now if you guys look in here, we can just display these values on the computer screen. But the computer programming, we are not just learning because we want to display some sort of values. So we want to have our code to have some sort of effect. Say for example, if you have expression A equal to say for example B, this is pretty much fine with the computer. As far as computer is concerned, this is pretty much fine, because we have value here, we have assignment operator here, and we have another one which is B, and we are closing this one. So now this two part here is expression, and as soon as you guys put this say semicolon, it becomes a statements. In everyday English, statements is something, when you guys putting sentence and we putting the full stop here, it becomes a statement. say exactly that's true with the computer programming. Say for example, if you have an expression, say this 1 plus 1 is pretty much fine with the computer, and as soon as you guys gonna put this one with the semicolon, it becomes a statement. So statements, in other words, that expressions that ending with the semicolon, now we call this one is statements. So as I said before, you guys have there is no use if you guys keep on doing this all day. You guys, even if you guys gonna put a plus plus here, it be still pretty much fine. But the problem is that if you guys don't do anything with this one, it's pretty much useless for you guys. So we're gonna remove this. For example, if you have int x equal to, say for example, 5, and if you have int y equal to have say for example 5 as well. So what are you going to do with this one? Now this two guys here, the x have a value of 5, y have a value of 5. So what happens if you guys do this one is 15? So there is no point, we are keep on declaring a lot of variables here if you guys don't use these variables. Say if I tell you to, can you compare these two, which one is greater to which? So what you guys gonna do? So C++ have inbuilt statements called if statement. So it's called if followed by this parenthesis here, and called statement. So the first one, the first part is that we're gonna put a if. This one's we put an expression. As I said, expression is like for example 10 is greater than say 5. Our you can put a 10 is less than say 5. Our we can do 10 minus, say for example 5, our plus 5 or something like that. So this is the old expression now, and here as soon as you guys gonna put a semicolon, then it becomes a statement. Means you guys completed this one. So as far as the computer C++ concerned, it means here you guys making expression, but here you guys are completing your expression and putting semicolon, becomes a statement. So C++, as I said, have inbuilt a function called if statements. It's called selection statements. So in general, C++ has a lot of statements, not just if, but it has a switch and all other sort of it's called selection statements. So we put a selection statements. So as I said, if you're gonna put an expression here and then followed by your statement here. So how does if gonna work here? So if you guys gonna put if, and if you guys gonna put the body of your selection statement, which is this guy's here, that guy's starts and this guy is gonna finish. So here inside you guys gonna put some sort of expression. So as I said before, instead of putting 15 plus minus or equal to whatever till 5, you guys just put this, the representative, which is x. So we put x. If x is greater than y, then we put a say c out. So we put a std and we put a c out, and then we put a x is greater than y. Okay, so here we just put a new next line, and here now, as I said before, because we are ending this C out with this semicolon, now this is a statement. As I said here, we put a if here, then we put an expression here. But if you guys look in here, there is no semicolon here, because we don't want the statement inside here, because if by itself is a statement, so we don't need this one here. And here, because we are making just one is cout statements, that's what we are gonna put this one, because we want cout to put something for us, so on the screen. So now our values here, whatever values here, is having some sort of effect. That's what we want. We just don't want anything to lying around. Say for example here you just don't want this a equal to b lying around. Our say plus plus c, our minus minus d. So these are, if you guys don't use your statements here, it's pretty much useless. By default, C++ have no issues with this one. Even if you guys gonna put this one, if say here, close your statement here, say you put a x plus y, there is no issues with this one. C++ has no issues. Even if you guys gonna put a equal to, this equality in C++, if you put your expression here, x equal to y, it means if you guys want testing this one, and if you even if you guys don't put anything here against this one, say C out, it means C++ has no issues with this one. It means this pretty much this is very correct statements. There is no issues with any of this. But the problem here, why you guys want to do, if you guys don't just want to just to put some sort of code and your code is not doing anything, this is pretty much useless. So now here our code is doing something. It means we are comparing this to here, which one is greater than which. So if we put it here, if our expression x greater than y, then if this one's true, then you guys display this one. So keep in mind that C++, every other language, as soon as this has to be true. If this part is not true, it means it's not going to display this one. So this has to be true. So we're going to hit the Control S to save, and we're going to build and run our program, and we're going to see our output. So x is greater than y. Alright, so now what if this value is false? Say for example, what if we put it the other way around? So now, because this condition is false, I don't think this is going to show, because even if you guys build and run, you're not going to see anything on the screen. You're looking here is empty. Why? Because here this condition is not meeting this conditions. Say this conditions is not okay with this one. So now comes in with else. So here, if you guys put else, here there is we put another one here, another statement here. So this is another part of this if statement. So if this condition is true, put it here. Otherwise, what if not, just put it there. So we're going to copy this one and we're going to put it this one. So the other part of this one is less than y. We Control S to save, and we run, and look in here, the second one comes in. So this part is called else. So if this part is true, show this one, otherwise show this one. You can put a lot of statements with this one, not just this one. Say for example, if you put a boolean, bool, say for example we put a b equal to, if we put a true, say we put a now if b here, because if true, we put a true, otherwise false. B is true, otherwise B is false. B is false. Control S to save, build and run, and we're going to say B is true because our condition is true on top here. If you put a false, then our B becomes going to be false. Control S to save, and we're going to build and run, and you're going to see here B is false. So this is called selection statements of if and else. Alright, so now we talk about the conditional expression, or one-liner conditional expression. What is a one-liner conditional expression? Say for example, we have a bool. Say if I can remove all these, I'm gonna put bool again, so I'm gonna remove these guys as well. Alright, so now if you put a boolean, say for example some sort of expression here, and we put this expression, say for example true. Now I'm gonna declare another variable, say for example a, and I'm gonna set this one on 0. So now we're gonna put a say a, and I'm gonna put this guy expression here inside, because now we want to put a one-liner expression which is the type boolean, and we're gonna put this unary question mark, and then we put either 1 or 0. This is exactly like the one you guys just saw before. We put a if else. So for example, now we have our variable here, we call it expression, and we set it on true. We have an int a. This a is, we set it on 0. So now this a has this expression, this guy here, the boolean. So this part is a boolean, and we say this boolean is true or false. So we're gonna put a cout. So we put a std, or we can put a cout, and we're gonna put the value is, we put the value of say a is, and then we're gonna set the value of a. We're gonna see if it's true or false. So we put a, and we're gonna put here our next line here. So now we're gonna check if our expression is true or false. So now we're gonna see, we're gonna build and run, and we see here that our value is 1 because it's a true. How about if we can turn it around and we put a false here? I'm gonna Control S to save, and I'm gonna run my program, and you're gonna see here the value is 0. So it means the first one, when it was true, they chose the this value. When this was false, it chose this value because the value is false. So this is conditional expression. Alright, so now we have tested this side, and on the left side of this column, and on the right side of this column. So what happens if you have more than 2 conditions? Say for example, instead of if else, say for example, if you have more than say conditions, what are we going to do? Because we have tested only 2 conditions, if it's true or if it's not true. So we're gonna remove this, and we're gonna see how we can create a program. Say for example, we have students, we are working for a school, and they're telling us that make sure we create a program here for us. So if the student's age is 5, the student is say is eligible for say kindergarten, for example. Or if the student's age is 7, we can admit the students on grade, say first, say prep, or grade 1. So how are we gonna do this? Say for example, we have int age, and our age is at the moment is 5. So we're gonna put a if, for example, in previously we're gonna compare it. We're gonna compare our the given number, that the student's age. Say for example, if age double equal is keep in mind this is assignment, and this is comparison, because we are comparing. If the age is say for example 4, then we're going to copy this guy here from here and remove it from here, and we're going to paste it just right here. And if the age is 4, then we're going to say that you're too young. You are too young, for example. And then we can put here, you're too young and your age is, and then we're going to display the age. Alright, so now if we Control and S to save, and we're going to run our program. Alright, so we make a mistake here, we should put age here. So we put an age because we want to see the age here in the console. The reason is that we did not see anything, because why we did not see anything? So if we put else here, else, and then we copy this guy from here, and then we're gonna paste it here. So if the age is, because our age is 4, then you are too young. But what happens if the age is not 4? Then you can be enrolled in kindergarten, for example, kindergarten. All right, because your age is for example 5. Okay, so now we built and run. You can be enrolled in kindergarten, for example, ages 5. But for example, what if the students, for example, is 7? What are we gonna do? Our the students 6, and we, because we want to compare every students from 1 all the way to 10. What are we gonna do? So if you can just put another else here, if you put another else, then the computer is going to be extremely mad at you. Why? Because you have too many else here. So what we're going to do to solve this problem, we're going to put else if. So else if, because we're going to put another condition here, and we're going to condition, say for example, if the age is 4, then you can be, say, enrolled. You're too young, for example, your age is for example 4. What else if age, for example, age is 5, our say age is say we're gonna put a age double equal to 4, for example. So here we put 3. So if the age is 3, you're too young. Say for example, if we put the age is 3, then we're gonna, the computer is just gonna compare the value, and we're gonna put this one, you're too young, and your age, and your age is you're too young, your age is 3. So we're gonna see this guy here, you're too young, for example. Or so if the age is for example, else if the age is here, the age is 5, age double equal to, say for example, 5, then you can be enrolled in kindergarten. Alright, so if we put another else if here, else if, then if your age is for example 7, then you can be enrolled in for example prep, for example primary school. So as you guys observe here, we have one if here, then we have else if here block, then there is another block here, and then there is another block here. And make sure when you have too many else ifs, the final part is that you guys need to put an else here. And this else just gonna say that if the user gonna put some sort of weird message, or some sort of a message, that some sort of character that the computer don't understand. So I did not understand, I do not understand, I do not understand. So we're going to remove this age as well. So now we have created full-fledged. Please try again here. So now we gonna, our program is expanded. We're gonna check so many ages here. Say for example, if the age is 7, for example, so we put a 7, and then we're going to check that our students can be enrolled in primary school because the age is 7. What happens if we put a, say for example, 10? Because 10, if you look in here, we don't have anything for 10 here. There is no comparison for 10. Our I do not understand, please try again. When the user, when we take input from the user, and the user puts some sort of weird message that's not in our system, this guy comes in. Say if the user put a 20, for example, 20 years old, we have to display some sort of error message that the user should try again. There is an error, or you can put oops, there is an error, or something like, so the user can try again. But if the user's gonna come in any age range which we have in our system, then we can enroll the user. So it doesn't matter if you guys can have 6 of this or 7 of this, but as long as you guys gonna put some sort of comparison, and if the age is here in our system, so if any of these blocks meets the condition, then this is going to be shown on the screen. And the final part is we're going to display some sort of error message here. So this is in this way. Now effectively we have created so many conditions, and if the user can meet any of these conditions, we have an answer for the problem for the user's age. But if they put a, say for example 20, the user is going to put 20, then we're going to display this one, that this is out of our scope, our range. All right, so now we have here a whole bunch of else if. We are in every block we are checking the condition here. So, and now it's too many else if, and what happens if you guys have a 6 or 7? Now the readability is very poor, because you guys going to get very confused very quick. But keep in mind the C++ is solved this problem, and we have a switch statement. So instead of all these, we have say switch. So instead of else if, we have a case. And in every case, as soon as it meets the condition, it breaks. If we remove this, for example, and now we're going to put a, instead of if, we put a switch. So the switch is going to come here, and inside here we put a condition. So switch, and we put a, what's the condition? Our condition is age. So that's our age, because that's our topic. And for example, we're going to change this one to 2. So here, in, as I said before, we have a case. We have a case 1, or we have a case 2. Say for example, we have a, we start from case 3. So what the case 3 says is that std, then we put a C out, just like before, and then we put a you are too young, for example. And here you guys just put a next line, and here you just put a you are too young. And keep in mind, every statement finishes with a break, so we have to put a break. And every switch statement has at least one case and one default case. You can copy this guys here, and you can put it underneath here. And here, instead of case, you guys gonna put a default. If you guys remember, just before we just put a here, I do not understand, error, I do not understand. Try again. So now if you look in, this is a minimum of switch statements here. But we can have a 5 or more cases, but we're gonna try the minimum. Say what happens if none of this condition met. So for example, now we put a 3 here, and we're gonna meet this condition here. So here there is a typo here, you're too young, and your age is 3. So now here you're too young, and your age is 3. So your age is 3. Your age is 3. You're too young. All right, so now what happens if we're gonna increase this to more? So we can do so, and if you look and observe here, our code readability has improved. So I'm gonna go a little bit up. I'm gonna bring this guys a bit here, so you guys can see the whole switch statement here. Keep in mind, you guys gonna put it here. You just put a say 5 here. Your age is 5, and you can go to kinder. Okay, so because the age is 5, what happens if the age is for example 7, and then we're gonna, your age is 7 for example, and you can go to prep. For example, you can go to prep. What happens if the age is 9, for example? So we can have a case for that. We just put your age is 9, and your age is 9, and you can go to say grade, say for example 3. Okay, if we put if the user is gonna put here say 7, we're gonna have the case 7 here. So instead of a lot of if else, we have a switch. Your age is 7, you can go to prep. What happens if the user is gonna put say for example 9 here? Then we're gonna display that the user can go to the grade 3, because we have a condition for every cases here. What happens if the user is gonna put a 19 here? 19 is out of our range and out of our scope, and here we do not have any condition, and you're going to see here because the user, our system is going to show error. I do not understand, try again. So this is a switch statement. You can put a say cin, and through in cin you can get the user's age, for example. Say for example we can put one of these studies cout here. We're going to copy that and we're going to paste it here, and please enter your age. So we put up please enter student age. Here we're getting the student age, and we're gonna set this age to 0. So here we're gonna put a cin std, we put a cin, and look at here, look at the direction of this guys here is going not this way, because here we are taking everything here and we put displaying on the cout, but here we are getting this one to cin. So here the cin, and then we're going to put an age here. So I'm going to copy this guy here and I'm going to display it on top, save, and I'm going to run. What's the student's age? Say for example 3. You're too young. Or for example we can put a what's the student's please enter student's age. What happens if you put a 9 here? Your age is 9 and you can go to grade 3. So instead of us, we provide here, we're getting this one from the user. This is the way we put it on the console, and this is the way we're getting from the user. We get through the cin. Look at here the direction of this greater than, and it puts everything whatever the user is going to put it inside this guy here age. And here we are testing our cases. Say for example if we put a 20 here, I do not understand, try again. So now this is a full-fledged program that you guys taking from the user and displayed on the screen. Now if you guys look in here, we have we getting some sort of information from the user, and if the information meets one of our cases conditions, then we're going to display it. Otherwise we're going to display this guy here. So now we're going to go on the iteration statements. So if we need some code to execute multiple times, we use iteration statements. We can call it loop statements. So iteration statements are statements that execute some code in a loop. The code in the loop executes 0, 1, or multiple times depending on the statements and the condition. So the first iteration statement that the C++ offers is a for statement, or you can say it for loop. If you guys observe here that we set the age to 0, iteration statements comes in exactly like that. Say we can put a say for example for loop. Commonly if you guys go on programming, you're gonna hear the for loop. So here we're gonna remove all these selection statements, switch, or you can say switch statements, and we're gonna declare our for loop. For example, for loops are very good if you guys want to do something in counting. Say for example int, we put I equal to 0 as like before, I is less than 10, and I plus plus. So this part we starts our loop, this part here we compare, and this part here we increment here. So we put a std and we put a cout, and here we put the counter for example, and here we put a I, and here we put a next line. Why we put a next line anyway? So if I don't put a next line, our program is going to be shown in one line, but when we put this one, it means it's going to show on top of each other. So we put the counter is, and we put a counter. So now our counter is going to count. It's going to start from 0, and then it's going to go all the way to 9, and it's going to stop. So if we build and run, and you're going to see here is all the way from 0 and none. Why? Now you're going to ask me why it's not 10. The reason is because we put it here less than 10, but if you're going to put equal to 10, then it's going to show the 10 as well. So now you're looking here, it's showing from 0 to all the way to 10. If you put here 1, counter 1, it starts from 1. So this one here, if you run, and it's going to start from 1. If you put a 2, it's going to start from 2. So there's 3 parts to this guys here. The first part is initialization, as we have seen here that we are initializing. And the second part here, this guy here, this guy, as we've seen here, that here we are checking to the condition. What's condition is that if you put, say here, the condition is here less than 10 now, it means we're going to see 9 here. But if you put it equal, you're going to see 10. This is a condition here. The last part is increment. That's the engine of this for loop, because it counts. It goes in a loop, one loop. It goes then again to the second loop, like a propeller, like a fan. It goes to the third one. Then keep on going on the loop till this condition is met. So once this condition is met, then the for loop stops. So keep in mind there are 3 parts in the for loop. The first one is initialization. Regardless of you put it initialize it from 0 1, the second part checks the condition, and the third part it increments. And for loops are used everywhere in programming, in C++, in Java, C#, every programming language you can see, you name it, is used and is widely used among all the programmers in almost every programming language in existence. Alright, so now we're gonna comment this guys here, because we're gonna need it with while loop, and I'm going to show you guys the similarities between for loop and while loop. But before that, keep in mind that we can use the for loop with the array. We have learned array previously. So at the beginning of this video, we have learned array. So I'm going to show you guys how we're going to find the elements of the array, because for loop is an iteration statement. So we get it iterates, and arrays also have elements. So how we going to iterate through the elements of the array? Say for example, if we have int x, or you can put an array or whatever you guys want to put it here. So we can put a, say, size 5, or you can put a size 7. You can put any size you guys like. So the element 0 is 100, then we put a 200, then you can put a 300, then you can put a 400, 500, 600, and finally we can put a 700. So we have a 0, 1, 2, 3, 4, 5, and 6 here. But all in all, it's 7, because computers starts elements from 0. So now, how about we're going to come here and declare another for loop here, and we initialize it from 0, of course, because we can initialize from 1 here as a case on top. We put int I, and we put a equal to 0. That's initialization. We mean this guy here, and we put a I is less than. So what's the size? We put the 7 here. So we put the size 7, and we have to increment I++. If you don't put increment, it's not going to go ahead and read all this. The reason it reads all this is because I++. So we put a std, and we put a cout here. So if you guys want the size of the array here, there are a lot of parts here, so we put the elements of array. And keep in mind this part, this guy, you guys can copy x and this part here, half of it, and we put it here, because we want to see first the elements. It starts from 0 all the way to up, and after that you guys can put this guy here, put I here, and what is this I? I is this elements here, and you can put a ij, it doesn't matter. The reason every programmer put I, because it's imaginary. So here you guys need to put another half bit here, close this guys here. So now what our array is gonna count this bit here. What happens here? So if I put it here, and if I put a next line here, now my for loop is gonna count this guy here. It's gonna go 0 all the way to 7th. So if I build and run, and you guys gonna see here the element of the array starts from the 0 all the way to 6, which is the 7th one. Okay, so how about this part? How we gonna display this part? Very easy. You guys just needs to come here, here just put this guy here, the whole one. So x, you put it here x, and just put an empty array and put an I here. You cannot put a 7. If you put a 7, it's gonna give you guys error, but we have to put I because we are counting the I here. So now if you guys look in here, we have effectively running full-fledged. So here we are counting every single here indices of this array. So the index 0 is 100, then index 1 is 200, then 3, then you go to 4, 5, 6, all the way to 6, because our arrays, as I say, starts from the index 0. So all the indices here all the way to 6. So this is one way effectively we are iterating through every single element of this array. So the computer comes and reads this guy here, then it goes in a loop, comes and read this guy here, then comes in loop and checks, oh, I have a 2, then it goes for 3, then it loop again, and there's loops again to 4, then comes and checks again, okay, because this condition is not met, so comes and check again, 5, checks here, 7, okay, then it said okay, I have another 2 more jobs to do, then it checks here, then it checks when it reads here, then it checks here. Every single iteration, it starts from here and checks here. So as soon as this condition is met, then it stops here on the 7th. And this guy here is the engine which boost and take off, and it helps this loop statement to come and reads every elements of this array here. So that's how the for loop is very effective in many to solve many programming problems. Say the first one is that we're going to see this array. So keep in mind the for loop is very effective way, as I said before, in solving many algorithms and solving many, say inside the algorithm there are containers, and they solve many even inside the search engines and inside they say e-commerce applications. It solves a lot of problems in and it works for even if you guys have an array of the size of million or 700 million or 800 million, it still works. But the only problem is going to take a long time for this loop to go through all of these single elements of this array. Alright, so now we're going to discuss the while loop. So instead of for loop, there is another version of for loop, is a while loop. Alright, so now we're going to get rid of these guys here. As I said before, that we're going to comment this one to check the while loop. What is a while loop? Just exactly like a for loop, we have a while loop. So I'm going to show you guys the similarities in a while loop. Say if we put for this guys from 0 and Control S to save, and if we run, we're going to see here that we're going to go all the way to 9. Alright, so what is a while loop? While loop is not used by a programmer because not many programmers like this guy here. So, but it's very effective. Why it's very effective? Because it's used in many games. Say for example, so if I'm gonna put it int, I'm gonna put an x equal to 0. So now, as I said before, there is a similarities here. Now the for loop, I have put the first part of these guys here. So the second part is that I'm going to use again this x is going to be less than 10, and here I'm going to put this guy here, the counter, or you can see the value, and I'm going to put it here. The value of x is the x is, and I'm going to put x here. Just keep in mind you guys need to put an x here, so for the counter to count. So here while now you are going to ask me, how about this guy here, the increment? So yes, fine, the increment here, the increment going to come here inside the body of while loop. So we're going to put here. So now whatever this guy is here, the components here, we have used it here in while loop. So we have used the int I is equal to 0, and we have used x is less than 10, and we have used this increment here. So here now, if I'm gonna put some sort of C out, so I'm gonna put a C out, and I'm gonna put some sort of line here, and I'm gonna put a std, and I'm gonna put an endl here. You can put an endl as well, and you can put a std here as well. So here I'm gonna separate both of them, and I'm gonna show you guys that both of them works very well. So now if you guys look at this, is a for loop, the first one, and now this is a while loop. And looking here, there is a lot of striking similarities between the for loop and the while loop. So int I is equal to 0, we have put int x is equal to 0, while x is less than 10, I is less than 10, and I plus plus. If you want to put equal to, if you want to include this guy here, and if you want to include this guy here, by all means you can do so. And if you look in here, that we're going to see 10 in each of them. So now you're going to see there is striking similarities between for loop and there is a while loop. And why do we use while loop anyway? While loop, the reason is that this has to be true. If this is not true, it's not going to go ahead. So say for example, if I put 11 here, because I put a 0, if this condition I have, if it's not true, then it's not going to go ahead. Say if I put this guy 11 here, now my while loop's not going to go ahead. Why? Because this condition is not met, because this is more than this condition. So my condition is not true. So when my condition is not true, it's not going to go ahead. You're going to see here that the counter is going ahead. For loop, the while loop did not go ahead. The while loop only goes ahead if this condition is true. So I'm going to put it here. This condition has to be true. This is the safe side. That's why the many programmers, they use this while loop, because for loop just goes ahead. It doesn't care if the condition is true or not true, anything. Even if you put this one here, it's the same effect, but you're looking here, this condition has to be true for the while loop to go ahead. So if I increase the number here, it means this condition is false, and since this condition is false, it means it's not going to go ahead. So that's the difference between the for loop, which is a iteration statement, and the while loop, which is also a iteration statement. And there is, if you notice here, there is a striking similarities between these two, and these two starts from the 0, and these two, all of them both checks here, and see while loop checks here again, and there is here the increment. Both of them have an incrementation here at the end, but the only difference is that the for loop have everything inside here, this parenthesis, while loop is everywhere. That's on top. Then you have here inside the parentheses, and then incrementation happens after this guy executes. The C out executes after it prints on the screen. So if I leave this guy is on 1 and this guy is on 1, and Control S to save, and you're going to see here in both cases that my loop's going to start from 1 all the way to 10. So this starts from 1 all the way to 10. So that's what the while loop and for loop. And keep in mind, you guys don't forget the while loop, because while loop have a very similar to the for loop. All right, so now as we said before, that if this condition is true, then the while loop's going to go ahead. What happens if you guys want, in some situations, I'm going to remove this one now, in some situations that you want the while loop to go ahead. Say for example, now if you put this one 11, say if you build and run, it means this condition is going to be false. It's not going to go ahead. You have what you see here is empty blank screen. So what happens if you want this to display this X? Comes in do while loop. So what is do while loop? Do while loop is these situations. For example, we have say we put a do, and this do now gonna cover everything. So even if this condition is false, we're going to see the our code. So for example, now I'm gonna remove all this. So I'm gonna say cout std cout, and I'm gonna put the value of x is, and I'm gonna put x here, and I'm gonna say next line here. I'm gonna put the value is, say for example now I'm gonna see the value, and after when I check the value, I'm gonna increment this guy here. I'm gonna put an x double plus to increment it because it's a loop, and then we're gonna check the condition if it's true or false. So when we check the condition, then we're gonna say x, x is then 10, and then we're gonna close this guy here and Control S to save. So now you're gonna look here that our condition here is false, because x is this guy here is not less than 10. So what we're gonna see here, if we built and run our program, and we're gonna see that the value is 11. If you look in here, well, before you guys couldn't see anything on the screen, but now with the help of do while, now we're gonna see this value comes in first. So now if you put, say this one to 15, because now this one's going to trigger, and the value here, now this is this is true, and the while loop's going to trigger. Look in here, the initialization is 11, 12, 13, and 14. Not including 15 because we haven't got an equal sign. So if you put a Control S to save, and if you put an equal sign, then you're going to see the 15 is included. So the do while loop is very rarely you guys see, you're going to see here in programming that is used, but it's useful if you guys have want to show the score inside your game, whatever games you guys creating, and you guys just want to show the value, but you guys don't want to see the counter or how it happens. You just want to show some sort of value, because you guys are going to come to different when you guys creating a game or a program, you're going to come to a situation where you guys wanted to say show at least some value to the user, not the entire value, but just show just one value like this one. So this is very useful in that situations. So this is called do while loop, and if you want to put it here, you can put it here, do while loop. If you want to write it down, you can write it down. Alright, so the next one topic that we want to discuss, and is extremely important, is constant. Our from time to time you guys going to see as a const. Why const is read only and is not modifiable. Say for example, as we said before, we had an age, and our age was 10. What happens now, you guys wanna modify this age. So I've got, if I put a std, and if I put a cout, and now I'm gonna put it here, I'm gonna put an age, and you guys look and observe here. So I'm gonna put a next line here. So I'm gonna put the age is. And now if you look in here, now we have a variable here of the type int. We put a name and we assign some sort of value 10, and here we just wanted to see our value on the screen. So if we build and run, we're going to see the 10 screen. What happens if I copy this again? Say for example now here, if I want to age, and I'm going to modify this age to say 20 for example. Now the age is, so if you have a program and the user enters his or her age, and the hacker is going to come in and change, modifies this one to 20, what the user is going to see, find out that inside your program the age, the value is 20, actually it's not a 10. So, and the user is going to be extremely furious. So comes in const. So const is when you guys put it here const, it means you cannot modify this later on. So if we build and run, and you're going to see here that there is no way then the C++ is going to say this is locked. This is locked and you cannot modify this age again. It doesn't matter how many times you guys run, it's not going to let you modify this assignment of read-only variable age. It means this is read-only. You cannot, you have no authority whatsoever to come and change this one. Why? Because we put a const. So now this is locked. Const is something that you cannot change it. It becomes now this variable, it becomes read-only. C++ offer the notion of symbolic constant, that is named object to which we can give a value after it has been initialized. So, and then nowadays, if you look in, if you have nowadays, if you look for the const, C++ gonna come in const expression. So now at the old time, it used to be const, just a const, the old programming. But now the C++, they included this expr. It means constant expression. It's exactly like the C, the constant. So if I put an expr, it becomes a constant expression. So if you try to build and run, we're gonna have the same, exactly the same error now, that assignment of read-only variable. So the constant expression, our constant, is very, very useful inside the C++. Say for example, you guys have pi, for example. You guys have a int expression and we kind of put it double and we put a pi. So we put a double pi, and you know that the pi, the value is fixed, so we put a 3.14159, for example, 159. Now we don't want anyone whatsoever from anywhere to come and change this the value of this pi. So the value of pi is and then we put a pi here, not the age, we put a pi. So if you guys gonna comment this guys here, we're gonna see our constant expression here. So here now you're going to see that the value of pi, another Mr. XYZ gonna come in and try to change this to say 20 point whatever. So we put a 20.7790, try to wreck your program, and here we're gonna put a pi here, and now the value of pi is and what do you think your program, because the C++ first to begin with is not going to go even ahead. Why? Because we are trying to modify this value and C++ have strong measures in place that anything that with the constant, our constant expression, the C++ will not allow it, and simple as that. As simple as 1 2 3, C++ is not going to allow it to be changed. So now this code is very safe and it's locked. So now this constant expression is a symbolic constant, and it must be given a value that is known at the compile time. Now if we put a double, for example, we're going to change it, so we put a max, for example. What's our maximum value? Our maximum value is going to be, say for example, 400. Alright, so now we're going to take some value from the user. We're going to put some sort of value. For example, we're going to put a int, and then we're going to put an n, and we're going to put a c in, we put a std, we put a c in, and we put our value this to n. From the, we're going to get it from the user. We're going to change this one to int as well. So here now we're going to do some sort of modification. So what we're going to do is that we put a constant expression, and we put an int, and we put a, say for example, a, we can put a1, and we put a here max, which is the constant expression here, and we put a max plus we put a 10. What do you guys think? Is it gonna show now the value of max is, and we put a max here, so we put a here a. So now whatever the user is going to put it from here, we're going to get it from the user, and we're going to display it there. So we're gonna run our program, and we're gonna here we need to put some sort of thing for the user to put something here. So we're gonna put a here cout, please enter some value. We put a std and we put a cout, enter some sort of value. So we put a enter some value, and whenever the user is going to put enter some value, then we're going to go on the next line. So now we're going to run, and now we're going to enter some value. Say for example, if we put a 20 and we look in here, that's the value is 410. So what happened here, that 400 here already we have it here, and because we have its const value, another const expression, we are not changing the value of this guy here, we're just putting 8. That's what you guys going to see here. So whatever the value you guys going to put it here is 410. Alright, so now what happens if we put instead of this max, which we had a constant expression, we put this guy here. Look at here, because now this one is not a constant expression, it's just a normal int, as the two values here, constant expression and constant expression here, it has no error, it given us no error, but now we are putting this guy here, which is just a normal constant expression. It's not even a constant expression, and now we're gonna get say error. Why? You look in here, they said the value of n is not a usable in constant expression, because constant expression and constant expression works pretty much fine. If this value is constant expression and here is constant expression, this max is working pretty much fine, but not this guy here, not with the normal one. So if I come and change it again, and if I have a constant expression max, which is 400, and if I have another one, this guy here, I'm going to put a max, and if you guys look in here, it has no issues now. So you look in here, my whatever the value I put it is going to take, but it's going to, at least it's going to show me the constant expression one, which is 400 plus 10. It's going to just ignore this value, because I did not put any value here. Even though I did put a value, but I didn't want to show it here. So that's how the constant expression works in C++. Keep in mind, if you guys don't want your value to be changed, you either guys needs to put a const. Our const expression is a symbolic constant, and here constant expression and constant expression works pretty much fine. But as soon as you guys going to put another value here, it's not going to be fine. So it's going to give you guys error. Alright, so now we're going to talk about functions. As we have, when we started here, I have introduced you guys to this int main, and you're going to see here that's curly braces open and curly braces closed, and it has a return here. This is a function. So from now on, we're going to go towards functions, and then we're going to start towards classes and object-oriented programming. So we're going to remove this, because by now you guys should be very confident to learn the functions. So what is functions? What is this piece of code here that we have seen already? So we can break our code into smaller chunks called functions. So a function has a return type, as I said just now. It has a name, and we can see that the name is a main, and a list of parameters in the declaration, and an additional function body in the definition. So as we can see here in our screen, this is a very, very simple function. This has a type, which is int, and it has a name, which is main. Why it has a main? Because when the C++ was written, or you can say C was written, they reserve a main spot inside the computer's memory for execution purposes. Whatever you guys going to do here, you need to execute here in this code. It's just like a Senate, or you can say inside the country, it's a capital. Inside the capital, there is where the president and prime ministers, they come in with their ministers and senators. This is where the decisions make. That's you guys can think exactly the same place. Whatever, even if you guys have hundreds of thousands of functions, if you want to execute your functions, you have to bring it here. So say if you want to talk, you got to go on the stage. This is where all the executions are going to take place. So a simple functions, and we're going to put it here. A simple function has a first to begin with has a type, and the type can be int, string, double. It can be any type, and followed by the function's name. So here we have a name here, and we put a two parentheses here. We put a two curly braces here, like that, and like that. And inside here is all parameters. So this is very simple functions. I'm going to put a star here to distinguish this one. You guys can see this one this way as well. So you're going to see your functions this way, or you're going to see, normally you're going to see this way, but normally you guys going to see this parenthesis here. So the main structure of the functions that you guys needs to look at is the type, and it has a name, it has a parameters, and this one is curly braces open, curly braces close, and this is called a body of the function. So inside here it's called the body of the function. So here is the body. So body of functions, very simple. You guys gonna have not just one parameters. You guys might have like two parameters, 3, 4, 5, as many parameters as you guys like. And as I said before, it's a body of the function, and this function is we are returning something. And in the case here we are returning 0. You don't have to return 0 in a normal function. You can return whatever. Say if your type is int, you can return int, as the case here. If your type is a string, you can return a string here. You can return int here. If your type is double, then you can return double. If your type is say any other things, say if your type is say boolean, you can return boolean here. What is a boolean? Boolean is true and false. So this is a very simple structure of the function. Alright, so now you guys might be wondering, what if we have a function that you don't want to return anything? Say for example, if you guys make a shape, because the shape you guys do not need to return anything. Say for example, if it's angle, you can type, but what is angle's got to do with the return? Say if I say to you hello, then you're going to respond something. Say if you ask a question, then you're going to respond. What if someone want to say something that it's not required any return type? What are you going to do? To solve that problem, C++ came in with the void type. So void, as the name suggests, it means nothing. And now we're going to see the function definition here. So I'm going to put it now. We're going to see the function definition. So the function definition is you guys need to come around here, and you guys need to declare. Say we put a void hello, and now if you put a return here, then the C++ gonna be extremely mad. It's gonna throw every book on you. So if you put a return, say you return 0, because this 0 is integer type. If you look in here, this 0 is integer type, but I'm returning integer type because I'm returning 0 as well. Or say for example, if I want to return 1, Control S to save, and you're going to see this one, the extreme C++ is gonna be very mad at you, because you guys are putting here void, and you guys are returning something which is unpleasant for the C++. And you're going to see here that the C++ did not like what we try to do. Return a statement with a value in a function, return void, and that's error number. You guys need to stay away from returning anything with void, because void, when you declare void, it means you are not returning anything. So you stay away from this one. So now I have a function called hello. I don't have any parameters, but I just wanted to display something. So what I'm going to do, is I'm going to put std scope resolution operator cout, and here I'm going to put it hello. I'm going to put the next line here, and I'm going to put a hello to all of you programmers. Okay, so Control S to save. So what is wrong with this function now? You guys are going to see here there is nothing wrong with this function. If we try to run, because now, as I said before, I have a void type, but I'm not seeing anything on the screen. And if you look in here, the debug here, everything's fine. And you're going to see here, I'm not seeing anything on the screen. Why I'm not seeing anything on the screen? So even if you guys do this, because I have a function now, I have a function, it's called hello, and these functions, I'm just putting something on the screen, stdout. I have no error here. If you guys going to see here, there is no red square here. Normally you guys, when you guys have an error, you're going to see red square here, but my program is absolutely fine, but I'm not seeing anything on the screen. And why I'm not seeing anything is on the screen, because first, to begin with, you guys need to, if you have a function, then you guys need to declare it. So we do the function declaration. Okay, so now we have a function declaration. You guys need to type exactly the same ones here on top. So you're gonna put a void, say for the hello. Okay, so once you guys done that, it's still, if you look in the screen, you guys not going to see anything here. Why you guys not going to see anything? Because now that we have declared, we haven't seen anything here. The reason is, as I said before, that if you want to have a say in a country, you need to elect someone. Like we have elected hello, and hello is our voice to go in the parliament and say something. Now we have also declared, we have elected this person called hello, and now this person needs to go inside the parliament, has to sit there and talk. So that's the reason we haven't seen this one on the screen. We are not seeing this one on the screen. So what we're gonna do here, that we have to add this guy here. So this hello is gonna be there. So we put a hello, and it's a type void. So this, once this hello is here, now we're going to see something on the screen. What we're going to see on the screen, this statement here, hello to all of your programmers. So once we build and run, you're going to see here, hello to all of you programmers, our C++ programmers. So we have seen the function definition, we have seen the function declaration, and we have seen how we're going to add for a function to execute. It's regardless of what you guys going to put it here and what you guys declare here, you guys going to see you have to put it here for your program to run. Otherwise your program is not going to run. If you guys build a very awesome program and you guys done your function definition, and then you guys done your function declaration, if you guys fail to put anything here, your program is gonna run, because C++, as far as C++ is concerned, you guys did not create anything, because you guys didn't put it inside the main. Because as I said before, that the main is the main area of the program to be executed. If you want to execute your function, you have to put it here. If you don't put it here, it means your program is not going to execute. Alright, so now you might be wondering why we put our function here underneath here, and we declare here. You can put say your function on top as well. So if you remove here, you can move this guy, just copy it from there, Control C to copy, move here, and it's just gonna work fine. So because what happens with the C++, it reads line by line. So it's impossible for you guys to just keep on adding all the functions on top of the main. So what happens that because compiled C++, the compiler reads all of these codes line by line. So as soon as it comes here and encounters this declaration, then it's going to look for this function somewhere inside, anywhere inside your files or inside your code. So that's the reason we put something on top here. Alright, so now we're going to talk about the parameters. As we can see here, you guys can have one parameter, or you guys can have two parameters inside the parentheses. So what we mean by parameters, so if we can remove this one here, parameters are very useful. Say for example, if you guys want to do multiplication, or if you guys want to say create something or something cool, or if you guys want to say put a string here, the parameter is going to be plays a very crucial role. All right, so how we what we mean by crucial role, if we have a int, say for example, we can if you guys want to put a square, you can put a square, and I'm going to show you how. So int square, because it's a type int, you guys have to put int here, and say for example we can put xyz, or we can put x here. So what happens here, if you turn here, say if you have x here, we put x times x. Alright, so now our functions plays a very basic role. It's a type int, data type int. We name it my square, and it has a parameter int x, and it returns. What it does is that whatever you guys gonna put here inside this parameter is gonna multiply it. That's the only function of this function. So now we're gonna declare it here. So we're gonna put an int. So we put a my, we put a square of the type int, and make sure you put your parameter here int x here. Your declaration should resemble here the signature. This is called the signature of your function. So this is the only the bare bone top signature of your function. So you don't have to worry about the things other the body of the function. This is called the body of the function, but make sure you put this signature on top. If you don't put this one, if you fail to do, say if you don't fail to put your parameters, then you guys are gonna have a very unpleasant result. Alright, so now here we can copy this guy here, or you can put your function here. So we put a my, we put a square of the type int, and here, and make sure if your function here takes a parameter here, then C++ expect you guys to put something here. So when you guys creating a function, and if you put your parameter here, say then you guys have a return here. Why I have a return? Because I have a type int. If you have a void, then you can put this one. So in your declaration, make sure you guys put exactly like here your function, and then here when you guys declare this one, make sure you put int x, and when you guys want to execute your function into bits and then you guys need to put your parameter here. So what you guys want to do, for example, if you want 5, because C++ now it takes the type int, make sure you guys want to put an int. You guys can put an ABC, or you guys can put a 5.5. You have to put an int here. If you don't do that, then C++ is going to get you mad. If you guys run that, and you guys going to see your result here. But we don't see the result. Why we don't see the result? Because we haven't done the cout. In order for you guys to do the cout, we have to create another guy here. So now we're gonna put an int, and we put a result, and that's our result. This is our result. So now we have to cout this one. We put a std, and then we put a cout, and you guys can put it here. My parameter result is, and then here you guys need to put this result, because we have created another variable, and this variable takes this function here. So you just put a result here, result, and here you guys need to put a next line. Alright, so now the case before, we couldn't see anything on the screen because we didn't do any cout on the console. But once you guys gonna create your the next guy here, you guys can see your result. So we're gonna build and run, and we're gonna see here my parameter result is 25. Why 25? Because here we put a 5, and here we are returning 5 times 5. If you put a 2, you're gonna say 2 times 2. If you got a 4, 4 times 4. Whatever you guys gonna put it here. why this is the best way. If you guys do it this way, say for example you can put this guy here as well, you can do that one, but this is the best practice. If you guys create another say variable here, and you guys assign everything whatever here as if you guys put this way, say if I copy this guy here from here, alright, so if I move that one here, I'm going to get exactly the same result. So now if I build and run, and you guys going to see here I have exactly the same one. And you guys looking here now, you see a bit confusing because here you have a function here you're declaring here, and here you have put your function straight here in the cout. But it's a best practice if you guys don't do this. So if you remove this and we put an int result like before, so you can put an int my result, for example. You don't have to put a result, and we're gonna paste here, and instead of putting this guy here, we just put this guy here, my result, because we name it my result. This is the best practice, and you guys see that one in C++ a lot. So here you guys don't need to put a parenthesis here. Why? Because this is not a function, it's just some sort of variable that we have just created now. So what is a variable? Variable is something that holds a value here. So what is holds a value of our function here? Because our function say take 5, so that's what's it's a value. So if you guys can put a 2, Control S to save, and we built and run, and you guys going to see here that's the result is 4. So this is now we have added one parameter in our function. Alright, so now you might be wondering, what if we have say 2 parameter here? We can do the 2 parameter, no problem. Create another function here. So I'm going to remove this one as well. I'm going to leave it here, this bit here, because we're going to see the result with 2 param. So we're going to put an int. Say for example we put a my math, for example. Alright, we have a function now, it's called my math. We change it, instead of my square we put a my math. So here you can create whatever you guys like, x, y, z, a, b, c, doesn't matter, as long as you guys remember your function name. So we put an int x and we put an int y. When you're creating a parameter, make sure you guys use this comma here, and make sure after the comma you guys create your when you're creating another parameter, make sure you put a data type. You guys just can't put a one int here and keep on going, you can't do that. So here you put a return, and if you guys want, for example, x plus y, or you can do x multiply, or you can divide, whatever you guys like. So now here, as I said before, you guys need to copy this guy here, the signature of the function. You guys can leave it, can put it here. So now here, as we call it parameter here, now here it becomes an argument. So here we can leave it like that, and instead of you can put my result, and here you guys change this one to my math. And if you guys look in here with the parameter, we don't have 1 but we have 2. So for int x, we can come here inside our function here, and we can put a 10, and for int y we can choose whatever you guys want. For example, we can put a 70, for example. Control S to save. Now if you look in here, we have a function called my math. We have 2 parameters here, int x and int y. Now what this function does is that it adds the 2 x and y. So here we have on top declaration, we already put our 2 parameter here, and here we have created a variable here. Now this function can sum to numbers here, so 10 and 70. So here we're going to see my result on the screen. So if we build and run, we're going to see 80 here. So now our function takes two parameter here. Alright, so now we're going to go a little bit back. Keep in mind this int here is your return type. Whatever if you guys are going to put double, you guys are going to return double. If you guys are going to put a string here, you're going to return a string. Say for example, even if you guys don't put this int and x and y, so here you just leave it empty. For example, you can return 50, for example, or return 90, because you have int here. You even if you don't have parameter, you can return int, but you can return a string here. So if my mate, if I remove this everything here, and if I remove everything here, and you're gonna see here that I'm still returning this 90. And you're going to see here that we are returning 90, even though I don't have any parameter here. Because I have an int here, I'm allowed to return 90 here because I'm returning 90. If you have a double, say for example, you can do 90.1. Say if you build and run, see here we are not we can return 90.10. Why? Because we have an int. If you guys want to change this one, you can do double. So in your double, now you can do, for example, 1 2 3, because now you're returning double. So here you guys need to change this one to double, and here you guys need to change this one to double. Okay, so now we have totally changed everything. Why we have changed from int to double? Because inside the computer memory, double have a special place while int have a special place. So double has more room for bytes than int. Int have 4 byte and doubles has more than that. So if we build and run, we're going to see our 90.123. And you're looking here, what before we could not see the 90.123. If you look in here, we have a 0.123. Why we can see now? Because here we have changed our data type. Our data type is now double, it's not int. That's why we can return 90.123. If you have a string, you can return a string, but if you have a double, you cannot return a string, our char, or you can say boolean. If you have a boolean, you can return boolean. If you have say int, you can return int. So keep in mind the top here is represents what sort of data you want to return. So normally this is your return type here. So that's what in C++ we call this guys here your data type, and you can at the same time we can refer this one as your return type. Alright, so now that we know that the arguments, we're gonna talk a little bit about arguments. So passing arguments. What is passing arguments in C++? So we put a passing arguments. As we have seen here, we had a parameter here, and say here we are putting some sort of value, and we are returning this value. This is called passing arguments. So in C++ there are 3 types. So the first one is we can pass by value, passing by value, and keep in mind this is very, very important because we are passing by value. And the second one is passing by reference, and the third one is passing by const reference. So what is the first one? The first one is passing by value. our slash copy. When we pass an argument to a function, a copy of that argument is made and passed to the function if the function parameter type is not a reference. This means that the value of the original argument does not change. An internal copy of the argument is made and the function works with a copy. So here we can say safely that if you have a double, or if you have an int, say for example my mate, we can have a double here, double x for example. So here we are returning x here. So now here in my double mate, for example, I have an x and I'm going to put a double x here because my parameter here is double because I have a type double and I call it x. So here I have a int my result and my mate now is going to take double arguments. For example, now you have to have a double argument. So you can put for example 500.90, and if you look in here my result, this program resembles exactly like so far we have doing that. So if we return, we're gonna see our 500.9. So this is called passing by value, because here we are copying this one in here we are copying here and we're passing to the say console. So here we have a parameter here, we call it x, we are returning this x. Here we are declaring our function and still we have this parameter. If you have a parameter here, you have to have parameter here as well. If you don't, then the C++ gonna get made. So here we have created a variable. Even if you don't create a variable, you're going to see that on the screen. So here we are passing this argument. So as I said before, this here is a parameter and it's here, this is our argument. So 500.90 is our argument. So now effectively we are passing by value or by copy. We can some folks copy by copy because what happens inside the computer memory, this one gets copied and here we are it gets passed on the screen. So the copy now in our say inside the computer's internal memory, this 500.90 is get copied. So when it gets copied, then we can show that one on the screen. Alright, so now we're going to talk about passing by reference. What is passing by reference? Passing by reference is quite the opposite of the passing by value, where it passes the copy of the value. So passing by reference passes the actual value, not the copy of the value. How are we going to do that? So in order for us to do that, we can do the double, and all we have to do is put the end at the front to make a reference. This is the most preferred way of when you guys do the professional C++ programming. As you guys going to see everywhere that all the programmers prefer this one, the passing by reference. So if you guys going to see this one every now and then, that when programmers they do say they wanted to pass a value, they are going to do this way. So for example, if we're going to remove this and we're going to remove the signature as well here, and we're going to remove these guys as well. So for example, if you are making the say profile of a user, say we are going to make a profile, and when the user is passing the date of birth, what are you guys going to do? Do you want to make copy of that user's date of birth? No, you're not going to make the copy. You guys want the actual value of the user. Say for example, if the users we're going to put an int and we put a DOB, date of birth. So what you guys want to do is that you guys want to pass the actual date of birth, not the copy of the date of birth. So what we're going to do here is that we're going to put a cout. So we put a std, we put a cout, the user date of birth is. Alright, so now we have got this DOB, so we can put a DOB for date of birth. Alright, so now we're gonna put a next line. So now what our we have a very simple function, and it's a user's profile. And what we're gonna do, because we want to get the user's date of birth, so and then we want to pass it. You guys don't want to mess around with the user's date of birth. You guys want to, whatever the user is going to put it here, and then we have to pass it there. We cannot just say okay, we're gonna make the value of or copy of the user's date of birth. That's wrong, because when you guys making C++ programming, you guys make sure that whatever the user is going to put it there, you pass the actual value, not the copy of that value. So we put an int if the user the date of birth is, for example, 1990, and then you guys want to pass this 1990. You guys cannot go there and make a copy or anything. You guys has to pass this 1990. So you guys needs to put here profile. So we're gonna put a profile here, profile, and then we're gonna put a user here. Okay, so you guys don't forget to put the signature on top. Make sure you guys declare your function here. Okay, so we Control S to save, and we're gonna build and run. And you're gonna see here that the user's date of birth is 1990. And as you guys know now, that in order for us to pass the actual value, we have to go through this guy here, passing by reference. This is the most effective way of you guys learning C++ and do the programming with C++. As if you guys gonna go in advanced levels of C++, then you guys gonna realize that this is very important to use this passing by reference, because passing by reference passes the actual value, not the copy, not the other way around. It just passes the actual value. If it's put it, say 2009, it's going to pass 2009, whatever you guys going to put it. So this is one way for us to make sure that our data, whatever the user is going to put it, is safe. And C++, our compiler is not going to play around with our with the user's data, not going to make a copy or do other stuff with the user's data. So if you guys want to pass the actual value, you guys always go with passing by reference. Alright, so now we're gonna go on the third one, which was passing by const reference. If you look in here, it has also, the third one also has a reference, but at the front it has a const. Why we do this? For efficiency purposes. If you guys don't want your data to be modified, make sure you guys always do this const. When you guys do declare const, just put a const here, and we can put a const here as well. You don't have to put an int. We can put a, say for example, a string. Say we put a std, we put a string, put an n here, and we put a, say for example, profile name, for example. So the profile name, and we put the profile name, the user name is, we can change it to name, and instead of DOB we can put a profile name. And now our profile name, if for example hackers come in and hack our system, they cannot, there is no way the hackers now can change the name, the profile name of our user. So here we put a profile, and instead of int we can put a std, and we put a string, and here we can do exactly like this profile name here. So we do profile name here. So what's profile name? and here put a std, and because you can't put an int, and you can put your name. So whatever name, say for example we can put a John. So here we have to name it, and name it for example name. So here in the profile, which is our function here, we just pass it here as argument name. Control S to save, and we built and run. As we can see in our program, the username is John. So now here, because we are passing the actual value, which is John, there is no way now our programs pretty much very secure. So the actual value is getting passed as argument, and there is no way our data is getting corrupted, our data is getting changed. Why is that? Because we have passed here const here. So const reference is very efficient than reference. So you guys make sure that when you do programming with C++, you always do this way. Alright, so now we're gonna talk about function overloading. So what is function overloading? Function overloading, C++ let us to define a function with the similar names. Say from now on we are because we are getting very advanced levels of C++. Now we know how to handle this std scope resolution operator. We're going to get rid of this, and we're gonna, instead of putting all the time here, we have an option in C++ to put it on top here. So we can put it using namespace std, because the reason we use it, because we knew all the time we were just a beginner, but now because we are in advanced level, you guys don't need to put it here, just put it here, and that'll do. So that one we're gonna work with all your whatever. You guys don't need to put a std all the time here. As I said before, what happens if you have a say function here, profile, if you are making profile program, what happens if you have say for example 3 profile here, and all of these functions gonna perform some sort of unique functionality. Say for example the first one is say for example if you have a char, if you have a character, and for example we can put a param. What is param? Is parameter here. So now if you want to do that, for example if you want to create the same function with the similar name, you got needs to change the signature inside. As I said before, you guys needs to change these guys here. You can leave the name the same, no problem with that one, but here you guys needs to put the char is, for example, and we can put a character, say for example param here, or you can put a name here. The reason we put a param, because all of them is gonna look the same, so I'm trying to make all of them look the same. So we're gonna finish the 2 as well. So I put an int here, and I'm gonna leave param here, and here I'm gonna put a string, and I'm gonna param here, or you can put a double here. If you look in here, I have 3 functions here with a similar name, but the signature is different. Look here inside here, the parameter is different. So the first one, the second one, and the third one, as you guys notice here, the first one is char, the second one is int, the third one is string. So here on top you guys needs to put it character param char, put it here as a parameter. The second one we're gonna put int param, and we put a string parameter. So we can put an int param, and the last one we're gonna put a string param. And here you guys change this guy here from here, and we put a profile. The first one is gonna be, for example, we can put a y, copy this guy here, profile again, and put it twice here. So here the second one is int. We're gonna put a, say for example date of birth, we put a 1992, and the last one is a string. We have to, you guys needs to remove this, put a double quote, and you can put your own name. Say for example, we're going to put a John here. Control S to save, and we're going to run our program. And if you look in here, our string, our function, our loading is working pretty much fine. The char is 1992, and the char is John. Why all of them say char? Because here we did not modify it. So here you guys need to put an int, and you guys need to put a string. If you look in here again, all of them sharing the same name, so it's a profile, but the only difference is here it's a parameter. So the first one is character, the second one is int and string. As you guys know here that C++ has no issues with the function with the similar names, but if you put a function with say same parameter, you guys going to be in trouble. So the char is Y, int is 1992, and its string is John. So this is called function overloading in C++. Alright, so now we're gonna come to classes. So we're gonna remove all of these guys from here, and we put a classes here. So what is classes? Classes is the main, if you guys look in here, IOStream C++ is mainly built on classes. The first time when the C++ came in, it was called C with the classes because it was one step ahead of C, but it has object-oriented functionalities. So the reason C++ widely popular and the reason is everyone uses is because of the classes. Because in C++ it allows us to have classes. Inside the classes we can create member functions, and we can create the constructors, and we can create destructors, and you name it, we can create a lot of methods inside the classes. So how to declare classes? With the classes, you guys need to just put a class. For example, we can put a my, for example, name. That's just a simple looking class. Alright, so now you're looking here that the Code Blocks IDE has finished it, and it puts here this guy is here. So it means this guy's means is end of class. If you put a class without this guys here, you're gonna get an error. But if you put this guys here, you're not gonna get error. Alright, so as I said before, that the C++ object oriented, it means we can have a classes, and the classes we can have instance. What is instance? Instance, say for example, if you have a class car, then we can have a lot of instance. Say for example, now if I'm going to change this one, I'm going to put a class, I'm going to put a my car, and you look in here, that's just a simple class. It's a very empty class, and you can look in here, we can use the name of this one class here in our main. So we put a car, and so now this my car, and my cars can be any car. So this class now is a blueprint. It means it can be any car, because it's a class. The class is a car, the category is car, and this car, because now this car is instance, is object in is my car. It's not your car or anyone else's car, it's my car. So if you build and run, you're going to see here that we are not getting any error. We are not getting any error here. We are not seeing anything on screen because we don't have anything in our classes. So this is a class. This guy is called class, and this guy is called instance of the class. And we can call the objects are instances of the classes. So now this my car is an object of class car. Alright, so now that we know what is class and what's instance of the class is object, now we're gonna see the data member fields. So we're gonna put it here. So data member fields, there is no class without the data. It means nothing. Just like humans, our car, if you have a car without radio, or without say a color, or without a seat, or without engine, it's not a car. So it's just like a human us, without a name, without a cloth, or without hair, or without any other properties that we have, we are nothing. So just like exactly same as classes, a class should have a data, and this data we can call it member fields, as I put it here. So here we can put a character, for example, character C. We can put a, say, int, for example, age, and we can put a string, for example, we can put a color. So now this class, for example, has data members, data member here. The first one is char, the second one is int, and the third one is string. These are called data member fields inside the class. Alright, so now we have our member field, data member fields. How about, but we can't do anything with this, say, char, int, color. We can't just come in here and pretend that we're gonna put it on some sort of things on some sort of information on the screen, because programming is way more complicated than that. We have to solve a problem, and to solve a problem, we can have a member functions. We already know what functions is. So in order for say our class to be functional, we need to have some functions here. As I said before, it's called member function. Say for example, now we can put a void. You can put anything you guys like. Say for example, do something, our steering wheel, our wash my car, our, you can put any function here. In this is called member function. Say for example, if you have a char, if you have int age of our car, and if you have a string color, we can have say car function, for example, car function. And here you guys need to close it. So now this is one of our member function which resides inside our class. Keep in mind, sometimes we call this as a methods. So when the functions inside the class, we call it methods. Alright, so now that we have a function, how are we going to define this function? In C++, we can define functions in two ways. Okay, so now I'm going to put a closer. What do we mean by two ways? We have a class, and we have data member fields, and we have a member function. So what we mean by say define this in two ways. Say for example, the first one, as I put it here, we can put inside the class. The second one, you can put it outside the class. So if you have a class car, we can put it here, void, because it's a type void. Make sure if you have a void, and then you put the car here, then you can put a class car, scope resolution operator, and we put a car functions. Now this is the second way. You can put your say cout, and we can put a here next line, and here close it here. We can put a my car function has a lot of functions. Our we can add another function. We can put a void, for example, engine size, engine, for example, size. So now that's our second function here. We can copy this guy from here and put it here. So here we can leave it here, car, and we can put this one as engine size. So we can change it, engine size. My car has a very powerful engine, has a powerful engine. So as I said before, there are two ways. The first way, you can put entirely, you can define it inside the class. This is there is no restrictions of you guys can do this. You can put anything you guys like. Say for example, my car color, because we already defined color, you can put it something else. You can make my car body color, or we can put a steering wheel, front of the car, or reverse back of the car. Say for example, you can make up anything inside here. But here you guys there, and as I said before, that's the second way of you guys declare your function. So this is outside the class. Make sure you first put the name of the class, followed by the scope resolution operator, and now we can put the functions. As I said before we are using the using namespace std. We used to do std with everything. That's why I introduced std to you guys. Alright, so now we're gonna fix this typo here. So we have as I said before, we have two functions here, and this guy is here, the same functions here, but we define it outside. So how do we gonna access these functions now? We know how to declare our data here. We know how to declare our function inside the class. Now we also learn how to declare our functions outside the class. So how do we gonna access that one? So in order for us to access, we can use our object here, my car, because you guys need to have a class. We already put it here. We put our object, so you can put my car dot, and you're going to see here that code blocks C++ gives us a lot of options. Gives us all our data, char, int and string. You're going to see here, and also our function. So if you double click this guy here, trying to access this function, so we want to see this one on our screen. That's what we want to functions here. So I'm going to put this one a little bit down, Control S to save. And if you want to run, and you're going to see here we have an error. Why do we have error? And if you're going to come here and check, it says void car functions is a private within this context. Why we have this private message? Because by default C++ has something called access specifiers. What is the access specifiers? Say C++ was taken from C, and C we have something called struct, and struct is a class. Say in C++ comes and change this one inside the C++. C++ deals all its data member fields and member functions are private. If you guys want to change that one, you guys need to put this one as say public. So we have a public here, and put a double colon here. So now the C++ gonna gonna change the permission. So you can say this one as a permission, just like a social media. You guys gonna have say if you want to put your profile as a public, private, or protected. Exactly, C++. This idea is taken from C++, because C++ have something called access specifiers. We can move this. If you want to put your data here as say private, you can do so, and you can put your function as a public. But if you put your public here, then it means now C++ gonna treat all your say functions, member functions, as a public. It's gonna publish to the world. So we Control S to save, and we're gonna build and run, and you're gonna see here that my car has a lot of functions. And looking here with just one line of code, we have changed this one. The beauty of C++ is we can put a private here. So now no one ever can come and access this data here. So with the C++, we have the same concept. With the C, we have same functionality, but with the C, because C++, as I said before, C has something called struct. We put a my struct. This struct is exactly the same as this class, but with the struct everything is a public. With the C++, by default everything is a private. That's the difference between class and struct. So as I said before, we have because now we have introduced this public access specifier, we can access everything except this guys here. But we can access these ones but through our function, which I'm going to discuss later on. So we have put our my car functions, and now I'm going to put engine size. So we're going to use again the same object here, my car. So I'm going to put my car dot. If you guys want to say engine size, double click on this guy here, and we're going to put a Control S to save. We're going to do build and run, and we're going to see here both our functions here, even though this functions outside the class, but we still can access these ones through the dot here. So this dot, we can put the name of the object here followed by the dot, and we can put our functions here inside this our member functions here. That's how we're going to access it. Alright, so as I said before, that when you guys going to put your data here, if you put a private, say if you put a public, then it's going to be no problem, you can access anytime. But the risk is any other program can access your say data here. So in order for us, but if you put a functions here, we can by all means you can access that one. What I mean is that, say for example, if you have int age, if you can put a value here, say any value, or you can put it underneath here, say for example int age, I'm going to try to access that one. My objects here, my car, and then I'm going to put it here dot, I'm going to put age equal to, say for example 30. I'm trying to access this age here, but because it's a private, has a private access specifier, C++ going to be won't let me. It's going to be extremely furious. Why? Because that's private. I cannot access that one. And you can hear int age is private within this context. If you guys want to access that one, you can put it public. But if you put public, then there is a risk that any other program can access your program here. Say instead of private, then we can put a public. If you put a public, then all of them is going to be public now. So when it's public, it means you can access your program with no issues. The reason we don't see it, because we didn't have any C out. If you put a C out, then you can see your say data here. So if I put a C out here, my age is, for example, my age is, and then you guys need to put a copy this guy here, my car dot my age, you paste it here, and then here you guys need to put a double colon here, and here now you guys built and run, and you're going to see here the age, my age is 30. Alright, so now we're going to go forward, and we're going to go up, and how about here, instead of say public, what happens if we put a private? So what happens now that this section and the whole becomes private? It means that we cannot access any of the parts. So it's a very good idea you guys leave this area of your data, whatever your data here, you guys leave it private. Plus, if you guys want to access this data, you guys access it through your functions here. So how do we do that? So here you guys are gonna put a public here. This is the recommended way of all C++ programmers. They do it this way. So this is the recommended way of every single programming language that is in existence in today's programming world. So here now what happens if we access this char, or we try to access this int age, for example. If you guys try to do that, for example, we're going to go here and we're going to see we have int my car, which is our object here, and we are trying to access this int age here. Where is this int age? Int age is here sitting on top, but now before it was public. If public means it's open for public. So now that door has closed, so it's not a public anymore, it becomes a private. So what happens now, we go to press Ctrl S to save, and keep in mind, you guys observe here that we are trying to access this age here. So we're going to try to build and run, and we're going to see here that C++ is not allowing us to access the age. So int car age is a private within this context. It means that's a no from C++. So how do we go here and access the age? So the only way we can access the age is through one of these functions here. Say for example, if we create another for example function here, we're going to remove this, and there is two functions lurking outside. So what happens here, if we car functions and car engine size, for example, we're going to create another int. For example, here we're going to put an int, say my age, for example, and here we put it here, for example, we put a C out, and here say my age is for example, my car age is, and then we want to put a try to our car age. So here you just put an age here. So what happens now is that effectively we are using this guy here, or you can use it color or something, because now here this the C++ knows that we have a function here, we have created a function, and this function is using this age. So now this age that we have created, we cannot we don't have any data inside here. So here, if you guys look here, we try to put a data, but this is out of the question because we cannot put a data here. So where we can put a data, you guys can either put a data on top. Say for example here, you guys need to put some sort of data here. Say for example, if we put a say 30, for example, that's too old. Say for example 10. So my car age is age, because now we are accessing this one, we have initialized this one. So here we are what we're gonna do, you're gonna put a 8 years old. Say now we put a, all right. So we have here we have put some sort of data, and later on we're going to learn how we're going to put a parameter, but I don't want to confuse you guys now because we couldn't put this one because now it's private, and when it's private you cannot put anything here in this section. So the only way you guys going to put it here is either initialize it from here, or we can do it here. But now we don't, because we are not in the constructor yet. Soon we're going to get to the constructor, and I'm going to show you guys how we're going to assign the value to our member functions. All right, so now how we're going to access this one. The way we're going to access our member functions is through our object. So here we're going to put our object, my car, which is our object, dot, and my age, for example, dot, and we put a my age. That's how we're going to access. So now effectively what I've done here is that I have put some sort of data here. I assigned 10, and now this age has got a 10, and I'm using this data from here in my say member function. So here I'm just accessing this function. Effectively I'm indirectly using this data, not directly. So if I so what happens here, because this one's not here, so what we're going to do, we're going to remove this one as well, because we don't need this. And what's going to do, we're going to run our program, and we're going to see here my car age is 10 years old. So what I'm going to do here, I'm going to put some space. If I built and run, and you guys going to see here my car age is 10 years old. So how did the C++ knows that my car age is? Because here we have put it inside the private, we have put our data, and we initialize this data, and here we are just using this data. We can use this data directly. If you guys try to say for example put an int, say my car dot age, and try to access, say we put a my car dot age, which is data, then you guys going to be in trouble, because as I said before, you cannot do that. And if you look in here, if you have a program and your program giving you error, if you're looking bump up to this one, it means this one is you guys cannot use this one. So that's the beauty of the C++. And C++ by default, even if you guys don't put a private or public, if you put a data, is by default it considers all its data as a private, unless you guys going to put a public. So if you guys specifically put a public here, then the C++ going to treat all your data here as a public. So if you guys want to further investigate this about the public, because C++, as I said before, is one step ahead of C. In the C++ we had something called struct. As I said before, in that struct is the same as like a class, but the struct, all the data are public. All the data member fields and member functions are public in a struct. So a struct is another way of telling you guys another way of class. So in C++ they introduced a class, but when the C was written, it was a struct. You guys can put say any name. So once you guys gonna put a name, then all the data here, whatever the data you guys going to put plus whatever the methods and functions you guys going to put it here, they all considered as a public. But in C++, that's totally different. By default, all the C++ deals treats all its data and whatever is here is as a private, unless you guys specify here as a public. But now the best way, then this is the best way, is you guys gonna put treat all your data to put a private, so other programs, say for example if you have other classes, they can come and access your as a data member fields here. The only way you guys going to access your data is through your methods here, or you can say the member functions here. So this is the safest, and this is the coolest way. And just I add one more point, is that when you have a class, only the say member functions inside the class can access the private part, private access modifiers, private part of your data member field. So only this guy within this class, no other classes can come interfere or access your data member fields, whatever you guys have here. Alright, so now we're going to talk about the constructors. So far we know the classes, data member fields, member functions. We have learned about the struct, and now we're going to talk about the constructors. Alright, so what is constructor? Constructor is that if you guys remember, we have created our object here. So how this object is created, say if you guys looking here, this car here is a constructor. So but you're going to ask me, this car is the name of this class. Yes, constructors has the same exact same name as the class. So what I mean by the same name of the class, we're going to remove everything. So we're going to remove these guys as well from here. So I'm going to save, and I'm going to run to get rid of this red square. So now we're going to see here that as I said before, a constructor is a member function that has the same name as the class. The constructor purpose is to initialize an object of a class. If it constructs an object and can set values to data members. If a class has a constructor, all objects of that class will be initialized by a constructor call. In short, when an object is created, a code inside the constructor runs. So the first one is that we're going to look at the default constructors. What is default constructors? If we call the constructor, if we create the constructor without any parameters or arguments, called default constructors. So if you say here the car, you can, as I said before, you can create the same exact same name, car. And now this car is a constructor. So if you put a C out and we put it here, hey, I am a default constructor. Hey all, I am default constructors. Or we can say constructor. Okay. And one more thing, make sure you put your constructor in a public. So if you want to access your constructors, make sure you put it inside the public access modifier. If you don't put it, then C++ is going to see this constructor that you cannot let, it's not going to let you guys access this constructor. So make sure you put your constructor in public access modifier. Alright, so now how we're gonna access this constructor? So what we're gonna do, we're gonna come here down where the main, we're gonna use the name of the class, which is a car. And if you guys if you guys want to put this one, this is actually the constructor here. So we put a XYZ ABC. You can put anything you guys like. You can even put a, say for example, A. Control S to save, and we're gonna run, and we're gonna see that hey all, I'm a default constructor. If you guys looking here, we did not put anything else except here we just assign a name here, and as soon as we run a program, the C++ is gonna look here inside the main, gonna execute here. The C++ gonna look at the car, the class, and they're gonna say, okay, there is object here, there is the instance called this process called instantiation here. So as I said before, this is called instantiation, and this instance objects are instances of the class. And I'm going to repeat again, objects are instances of the class. And what is the class? Class is a blueprint. of anything. For example, car, our human, our tree, anything you guys think. You can, if you guys want to make objects. So how we're going to make objects? We're going to instantiate object. We're going to instantiate this class, and we're going to create objects. So how do we going to create objects? We're going to create objects through the constructor. And if you look in here, we have a constructor and we have a name. If you guys say, for example, create a class, and if you guys put some objects here, is by all means the C++ by default has a constructor behind the scene. So it is, even if you guys don't put it here, if you guys don't put it here, because initially we have instantiated object here, we have created object, and we are using objects with our data members and member functions, but we didn't only put any constructor. So yes, by default C++ has another constructor that runs behind the scene, is instantiate all your objects without any issues. So this is the beauty of C++. Alright, so now what happens if you guys want to put some sort of data here instead of say if you put it in private, you can put it in private, but I'm going to show you guys in public. Say for example, if you have an int, for example a, and you have int, for example b, or you can put an xy or anything else. So what happens now? You have a data. You guys needs to put here your data, and I'm going to remove this. Here you guys can put a parameter, any data of parameter, any number of parameter inside here, inside your construction. You can put a 2, you can put a more than 2, you can put a say 10. C++ not gonna stop you guys from putting any number of parameter inside your constructor. Say for example now is int a, we gonna put an int a, that's int a, and if you're gonna put int b for example, or you can put xyz. So now you guys needs to put your specifically put your data in your constructor here. So how do we gonna do that? We put a which is on top, and make sure this guy is here. You guys needs to assign this one, this a, to this guy is here, and then then we do the same process. We're gonna put a b here, and we're gonna put that the top one, the bb. This is the best way of you guys can use your data with your constructor. This is the preferred way. It doesn't matter if you guys gonna put it into age, or age of the car, or the power of the car, any number of whatever data you guys gonna put in, and you can put the same number here that matches here, and you're gonna assign it here. This is the golden rule. So how do we gonna say how do you gonna see how our data is gonna be instantiated? As I said here, that's the only time that you guys wanna, if you guys wanna create some sort of instantiate some sort of object here, you guys needs to invoke your constructor. Okay, so now because we have parameters here, you guys needs to put a say parenthesis here. So how do we gonna do that in C++? That's how you guys gonna do it here. So you guys gonna put the first one, the first int is 40, and the second one we're gonna put 70. And here you can access your data here. So what we guys gonna put a C out, and here you guys can put it the numbers are, and here you guys can put your number. So how do we gonna put our number? We can put our say object, which is a. We can put our object here, and then we can put our data. What is the data? Our data is also a. For example, you can put xyz. So our data is a, our job to objects a, and here we can put the rest one is that a dot b, and here we can put the next line. Control S to save, and we're gonna run. So the numbers are, we have 40 and 70 here. So here I'm gonna put a here space in between, and here you guys gonna see here that the numbers are 40 and 70 here. So I'm going to run again, and we're going to see 40 and 70. So here, if you guys observe here, we had an object or a, and we have a data as also a. C++ very clever to go. You guys are gonna know that this a is an object, and this a is a data is very clever. If you guys gonna put X, for example, here is X and Y, C++ can differentiate between your objects, and it can differentiate between your data. So now we have two data, and here inside here we have put some parameters. We assign our parameter to our data, and here we have invoked it, we have instantiated, we create objects with the two parameter. If you guys gonna put here, and if you don't put it here, you guys gonna be in trouble, and your program is gonna crash. So now you guys looking here, what happens if you have if you want to bring a lot of other data here inside the body of the constructor, then you guys going to be very confused as to what to do, which one is which. So there is another way, it's called member initialization. What is member initialization? So member initialization is a way to initialize an object of a class, is to set the constructor member initializer list in the definition of the constructor. What I mean is that you guys can do exactly the same process here. You guys can put a 2 colon here, bring this A here, open quickly brackets open and close, and here you guys need to put the B here. So now the B here is a bit confusing, but what we're gonna do inside here, we're gonna put this, bring this A here, and we took this B here. So what happens, the next step is that here inside this, you guys need to put this guy here, and you guys need to put this guy here. So here the BB comes in. So this is exactly the same as before, but this is called this is more clean and efficient way. This is more professional way. So now here that's exactly the same process, is that we put an A, we assign this A to this A. This is old style of programming that we used to do inside the body, but now the C++ evolved and changed, and this is more efficient. When you guys gonna put a colon here, it means that the rest is gonna be, say, for a type or access modifier. So this is if you guys gonna put A here and assign this parameter here, constructor parameter here, to this A, to your data, and here this B is another data which is with the type int, and you guys gonna put here your parameter, constructor parameter here. So if I control S to save, and if I build and run, I'm gonna get exactly the same one as before. As you guys look in here, the numbers are 40 and 70. There is no change. The only things change is this guy here. So now you guys have the whole body of your constructor. You can do whatever you want, and all your data here, assignment and everything is on top. So you guys not bother anything. As soon as you guys gonna come and see the code here is more cleaner and more efficient with the member initializer list. So you can put it here, member initializer list. So, and from time to time you guys gonna see here with the C++ constructors. All right, so now we're gonna see the destructors. So what I'm gonna do here, I'm gonna put it here, we put a destructors. Same as C++, when we create some object here, this guy even instantiate here, we can destroy it. So how do we do that? I'm gonna remove everything here from here, and I'm gonna show you guys how we're gonna declare our constructor outside the class. So here I'm gonna show you guys the destructor. Say for example, if you have a car, we can say car here. As I said before, the constructors are just the functions. So this function is special function to invoke, so we can invoke, instantiate, and create objects. So what happens when the constructor constructs something like a building or something, then we can have some sort of demolisher. If you guys need to put a tilde and just put a constructor here. So now this is called destructor. This destroys the object. When these guys create the object, this is going to destroy the objects. So from time to time, you guys are going to see your constructors and destructors outside the class. As I said to you before, constructors is just like member functions, special member functions that C++ allows you guys to create and create your object and instantiate object. What I mean, just like before with our member functions we have created outside, we can do it exactly the same one as we can do it now. So how we're going to do that, we just put the name of the class, a scope resolution operator, and just put your constructor here. So once you put your constructor, and we can put something inside the constructor, we put a C out, so to know that this is constructor, and here I'm gonna put a next line, and I'm gonna here put it here, the constructor. This is the constructor is invoked, and same as here I'm gonna put the name of the class, and I'm gonna put a tilde, and here this guy is my destructor, and here I'm gonna copy this one because I'm feeling a bit lazy. Here I'm gonna put the destructor. The object is destroyed, so the object is destroyed. For example, the object is created. The object is created. So on the top, this is where you guys call. Make sure once you guys put your constructor outside the class, make sure you declare it here. If you don't, then the C++ got no idea what you guys talking about, the constructor or destructors. So here you guys used to put your class car here, and you can put X here. So now this X is going to tell everything to C++ that there was a constructor, and this constructor is gone, is created, and again this is gone. So this X tells you guys don't need to do anything else. So what I mean is when you guys control S to save and run your program, and you're going to see here that object is created and the object is destroyed. How do the C++ knows? Because here we have instantiated our object, and here as soon as the C++ going to encounter this object, then it's going to look for the constructor. We're going to find the constructor. We're going to look inside the body of the constructor, and then it's going to encounter the destructor. Destructor is here, and it's going to look for inside the body. It's going to create the objects here, and it's going to destroy it straight away. So now the object is gone. Once you guys going to put destroy your object, it means this object is no longer inside the computer's memory. The object is gone forever. Every time you guys create objects, you guys can destroy your objects. Just put a tilde and put the name of your class here, and make it this is going to now make this destructor. Alright, so now that we have understand how we're going to create our objects, how we instantiate objects, and how we're going to create the constructor and destructors. Now it's time for us to talk about the copy constructor. So what is a copy constructor? Now you guys might be asking me, we have learned constructors and we have learned destructors. So copy constructors here. So copy constructors here is when we initialize an object of the class with another object of the same class, we invoke a copy constructor. So if we do not supply our copy constructor, that compiler generates a default copy constructor that performs the so-called shallow copy. So for example, if you have a object X here, you're going to create another object Y, and you guys going to assign this object X here. So for example, now we have I'm going to remove this destructor here. Now we have an object here X, and we have created another objects, and we're going to assign this X to this Y. So now we have we're going to get error. So if you go to look at the error here, undefined reference to the cars, for example. Now here we should create some sort of constructor, and we should create some sort of destructor. Okay, so now what we're gonna do, I'm gonna create another private access modifier here, and I'm gonna create int for example X, and my another variable is gonna be int Y. I'm gonna leave this one here. So here I'm going to create int XX, and I'm going to put int YY here. So now this constructor have a two parameter. I'm going to assign it int XX and int YY with my member initializer. As I said before, you guys can put X here, and you guys can put a Y here, and here you guys need to create your body of the constructor. So here when you're going to put an X and Y, you're guys need to put your parameter XX, and you're going to put a YY. So this is constructor. So as I said before, you guys need to put some sort of value here. You guys if you guys put it here, constructor is invoked. So constructor is invoked. Okay, so now if our constructor is invoked, for example, if you have delete that one, we're going to put a obj car. And if you put some sort of value in your object car, for example, we can, for x you guys can put a say 100, and for y you guys can put a say 700, for example. We control S to save, and we're gonna run, and you guys looking here, constructor is invoked. So what happens if you guys have create another object and assign this object car to that objects? We can do so. As I said before, if we do not supply our copy constructor, the compiler generates a default copy constructor that perform the so-called shallow copy. So here I remember, if you guys recall what we have learned about the passing arguments. So passing arguments is, we said there is three passing arguments, arguments by value and by reference and by const reference. So that's we're going to do in our constructor. We're going to do exactly like passing arguments by const reference. So we're going to put a const, and we put a car. You guys need to put an end, and you guys need to put some sort of say name here. So that's exactly what we have learned. We are passing by argument by const reference here. We are referencing this this guy here on top. So here you guys need to put your, remember, initializer. You guys need to put your values here, x, exactly like this guy is here, but the only difference is here we're going to modify it here. So here we're going to put an x, and we're going to put a y. In your this guy here, remember initializer list, that's exactly like that. And here inside here you guys need to put a aa.x, and then you guys again use this one here, aa.y. And you guys, if you're gonna copy here, and we put some sort of say C out, that the copy constructor is invoked. So how do we going to invoke now this one? So now that we have another constructor, and we are referencing to this, the first constructor, how are we going to invoke this one? To invoke this one, you guys need to come here and create another one here, another object here. So we put an object of car, we put a 1, you guys can put a 2. So here we're going to assign this guy to this guy here. So we're going to copy that guy here, and we're going to put it here. Now we have assigning this guy here to the second object, because we want to invoke this guy here. So if I build and run, and you're going to see here that the copy constructor is invoked. Now we are doing, as I said before, we are doing shallow copy. What happens if you guys want to say, for example, deep copy? So the default copy constructor does not correctly copy members of some type. For example, if you have a pointer or arrays, in order to make copies properly, we need to define our own copy logic inside the copy constructor. This is, as I said before, referred to the deep copy. Say, for example, what happens if you have a pointer here? Say this y, if this y is a pointer. Then if you're gonna continue with this one, we can't make it, because this is not gonna copy properly, because I said before, that's the before that was shallow copy. But what happens now if you guys wanna, for example, deep copy? So if this guy here, I'm gonna put it down, so, and I'm gonna put it int, and now this int y is pointer. So here you guys have this constructor here, x-axis and y as parameters here. You guys don't have a pointer here, the first bit, but the second bit you guys need to change it. How are we going to change it? So if you have a y here, so we put a new int, and inside here you guys need to create another guy here. So if you look in here, now we have, because we have a pointer, we are using the new keyword here. And with your copy constructor, you guys need to bring your pointer here. So now we're gonna leave it as double A. this part, because that's this is not a pointer, we're going to leave it like that. So where it says y, then we have to put exactly here, we have to put a new int. So we put a new and we put a int here, and I'm gonna put the one here, and make sure where it says AA.y, you guys need to put a pointer here. So copy constructor, deep copy constructor, for example, deep copy constructor is invoked. We have changed it, and we're gonna run it, and you're gonna look here. We have done deep copy. This is called deep copy constructor. If you guys wanna, the one before was shallow copy, but now it was the one before wasn't working. It wasn't good for say for example if you have array and pointers. So if you have a pointer here as your variable here, then you guys needs to put this guy here, needs to change with the new int. If you would leave it like before, only the int member is going to copy it properly, and this guy is here, it wouldn't be copied properly. Only this bit would be copied. Say for example if we have a default constructor here, and if you leave it like before, as I said, only this bit would be copied, and this bit wouldn't be copied, because their default ones not very good with the pointers. So now that we have a pointer, we are using new. This is using this new keyword. Is what we're going to do is that we're solidifying. We are making proper copy of this guy here. Alright, so I congratulate you guys to make this far in C++. Now it's time for us to talk some fundamental building blocks of object-oriented programming. Say for example, such as inheritance, and later on we're gonna talk about polymorphism. So inheritance, what is inheritance? Inheritance is when we can build a class from existing class. Said that a class can be derived from existing class. This is known as inheritance, and is one of the pillars of the object-oriented programming. So when, as I said before, that when the C++ came in, it was called C++ with classes. And the classes is one of the basic building blocks of the C++, is object-oriented, or you can say OO. So say for example now we have a class car. This is a base class. We can build another class on top of this class. So how do we do that? Okay, so I'm gonna remove all these, and I'm gonna remove all this. Say for example we can see in the real world we have a father, or we have a parents and children. This we can see in the programming terms. This is a base class, and this is a derived class. So we can see this one parents as say base, and children as derived class. If I tell you guys to interpret this one in the programming terms, we can see this one as a parents as a base and children as a derived class. Sometimes you're going to see here as a child class. You're going to see here programmers every now and then they're going to talk about children and child classes. So now if I put this one parents, we can see this one as a base class, and now we're going to come here as there is another class which going to take everything from this base class. So child classes are going to have all the goodness of the say base class, just like in everyday programming, everyday life. So if the parents have a nice house, children is going to inherit that one from the parents. If the parents have $1 million or $1 billion, children is going to inherit that. So whatever is the goodness of the parents, whatever they have, the children are going to inherit that one. That's exactly with the programming. So whatever the goodness of the base class, whatever the base class has, the children can access that one. So here we're going to put a derived class. So derived class, and then how the derived class going to inherit everything from the base class. You guys need to put a colon here and just put a base class, whatever class you guys are referring to, and then you guys need to put a say public. And why we put a public, I'm going to discuss shortly. And we're going to put a base class, base class. So now effectively this derived class going to inherit all the goodness of this base class. Alright, so as I said before, now these two classes have a relationship. So if you put a public here, and if you put a string, for example, a name, or you can say family name, I'm going to put it family name, and if I put int x, for example, so now this derived class with a child class going to inherit this too. So how it's going to inherit? If we're going to create an object, for example, we're going to create an object of this class, not that class, not the base class. So we put a derived class as a d object obj. You can make it something else. So now this d obj going to access this too. For example, now if you put a d obj dot family name, you can make up some sort of family name. You can put a McDonald, or I'm going to put a McDonald. You can put something else, and dobj dot x, for example, you can put some sort of integer, for example 20. And if you put a cout, and here if you put the first one, this guy here, family name, so I'm gonna put a d obj dot family name, and here I'm gonna put some sort of string, say dobj dot x here. So here you guys can put a family name is, and here you guys can put some sort of int is. For example, you can put an address or age, whatever you guys want to do. You guys can put it here if you guys want to see that on the screen. And if you build and run, we're gonna see family name is McDonald, and x is, for example, 20. So int, you can put int is, and if I run again, so int is 20. So now as I said before, we have created object from this class, not the base class, because now here we have public, and here it has a public part. This public derived class can access all the goodness, say for example all the public part of this base class, as we have demonstrated here. Now this derived class have accessed the family name and int x. X means anything. You guys can put an address, you guys can put a family number, whatever you guys want to put. So you guys see here that this object of this derived class, which we call it d object, is a made up d object. You guys can create something else, has accessed this part of the base class. Alright, so now how about if we change this one to say private members, as we have seen that is pretty much fine. The derived class can access the private part of this base class. But how about if we put this one as a private? Can the derived class can access? We're going to see that this one have a problem now, because if you look in here, this not gonna, you can't access because that's a private. So the private members on top of say base class here, you're going to see here that the string base family name is a private within this context. So this is called the access specifiers here. So now how about if we put this one as a protected? So far we have seen private, and I'm going to introduce you guys. We have another member class called protected. So now this protected members we're going to see, and we have seen the private. Now you're going to see here that in the case of the protected members, it's not going to access as well. So int base class x is a protected within this context, so family name is also protected. So now we have seen that in the case of inheritance, the derived class cannot access the protected and private parts, private members of the base class. The only time we can access is the public. So if we change this one to public, like before. And if you build and run, then the C++ has no issues accessing the family name and int of this base class. Alright, so now how about if we put a public here, the same as base class, we put exactly the same public member in our derived class, and we just introduce one variable here. What do you guys think? Is it gonna work here? So we're gonna try. So here we're gonna put a public here member, and here we put an int. For example, we put an age, because if that's a parent, then this is going to be child. So this child have age of his or her own. So here you guys can initialize here, say dobj dot, you guys can put this age here. Age, you guys can put a 30. Okay, so now here we can put another cout to see if we can access this age here. So we're gonna put the age is. Alright, so now here we can put this dog. We're gonna copy that one and we're gonna paste it here, and here we're gonna, you guys can instead of this next line, we can put an endl, because now that we are in advanced levels, you guys know so much about C++, we're going to use endl. Endl means end of line, so instead of using next line, we can use either of them. So now we're gonna, okay, so looks like we have a problem here. We have a typo here, so we're gonna run again. We had a typo, instead of cout we put something else. So alright, so you guys gonna see here the family name, and int x is from the base class, and the second one age is from our derived class. So you guys know that by all means we can access pretty much all the variables and attributes from the base class, and all the variables and all the goodness from the derived class with no problem. Alright, so now we're gonna introduce you guys to the class hierarchy. What is class hierarchy? Class hierarchy is when you guys create another class. Say for example, now we're gonna put instead of this derived class, we're gonna put a second derived class, or you guys can put a third generation here. If that's a parent, that's the children, that's the grandchildren here. So we can put a second derived class, which is going to inherit from this guys here, from the derived class. So we're going to copy that one and we're going to paste it here. So here now you guys can even copy this guy here into age. We can make up our own. So now we can put a public. For example, we have used a string, we have used int. Here you guys can use the double, for example. So we put a double, we put a height, and now you guys looking here double, you guys can put a money, or you guys can put a length, height, whatever you guys wanna put. You guys make up something. So now that we have a second derived class, if you guys wanna make objects, you guys always make the objects of the last one. So here instead of derived class, you guys can create a second derived class. If you can change this one, up to you, but I'm not going to change this one. I'm going to leave it as it is. All I'm going to change this one is this guy here. So let's leave it as it is. So here in the height, you guys can put a dobj dot. We can go all the way to height. It's a double, and the height you guys can put 180. Say for example 6 foot. For example 9 inch, 6.9. You can put a 6 foot 6.9 here, and you can copy this one here, put it underneath, and here make it like that here and put the height is, and here dobj dot height. Yeah. So we built and run our program. Now we're gonna see the family name, the age, which is from derived class, and the height, which is the second derived class. You can think of this one as grandparents, and this one as your parents, and this one as us, our we. So this is us at this age and time, that's our parents, and that's our grandparents. That's a base class. That's what you get our family name, our DNA, our genes, whatever you guys think, we get it from here. And here our parents get it from their parents, and we get it from our parents. So here that's us. This is our objects. So we live down here in existence at the moment, because whatever you guys gonna put, you guys always put the last class. This is called class hierarchy in object-oriented programming. And inheritance is very important. You guys need to learn if you guys want to create different classes. Alright, so we are approaching to the end of our video. So far we have learned class hierarchy. So we have learned the base class, we have learned the derived class, and we have learned the second derived class, as I said before. If we see this one as a parent, this one's as children, and this is as a grandchildren. Alright, so now we're going to talk about the polymorphism. So here I'm gonna remove this one's classes, because now we are expert in classes. We're gonna put a polymorphism. What is polymorphism? Polymorphism is the ability of something that have many shapes. So here remove the class. I'm gonna put a class base class, because we need this base class. So polymorphism, as I said, has ability something that have many forms. Say for example, if you have a base class and derived class, if you guys want to create some sort of function that the derived class can use as well, you guys can use this polymorphism, and it's very useful. Say I give you a simple example in real world. If for example have some Bollywood or Hollywood, if there is an actor, I'm going to put it here as a parent actor. So now this parent actor, for example, comes in film industry, and now here as a child actor, and this child actor goes and inherits everything from the parent actor. So it's, you guys put always uppercase with the classes. That's a very good idea if you put your first letter uppercase. And here now we have a parent actor, and this parent actor comes in the film industry, for example, and starts acting. And we can use virtual void. For example, we put acting as a starting point. So now here this guy here comes here, and say for example what he does is says that hi, I am a famous actor, for example. Okay, so now here we put an endl. What happens now that this we have a method here, famous actor, we can instantiate this one, but now doesn't matter how many child comes in after his parents, they're gonna inherit the same acting. This guys can inherit, then his children and grandchildren, class hierarchies, so on and so forth, can access exactly the same one. So what happens here, I'm gonna show you guys how we're gonna instantiate this one. Say we have a parent actor, and we put a parent actor here. You guys need to put a pointer, and we put a p parent obj equal to new parent actor. And now if you guys know that we have this, use this new. So new, we are using the parent actor, we are pointing towards this parent actor, and we are using new because we are instantiating this one against this guy here. So how we gonna access this guy here, the void acting. So we could use here our parent obj. So parent obj, and we use the arrow operator. So what happens, the arrow operator is going to dereference this guy here, this class, and it's going to access this acting here. So we put acting. If you guys have used the Java, our C#, our PHP, you guys gonna know this arrow operator. So this arrow operator is going to dereference this guy here, and it's going to access this function here. So if we control S to save, and we want to run. So now if you guys look in here, we have put this one, but we forgot our public here, public member here. You guys need to put a public. As I said before, in C++, all the classes by default is a private. So that's a very good reminder. If you look in here, it says that virtual void parent actor act is private, because we didn't put our public member here. So you guys need to put this public member in order for our program to run. So we forgot to add this public member, and if you guys look in here, it says, hi, I am a famous actor. So as we can see here, that through this arrow operator, it means we are pointing toward this object. So in C++, in PHP, and in Java, we're going to use this one as this. So this is arrow operator. It means it's pointing towards the object. So it dereferences this pointer, this guy here, and it's using this one. So this new is inside the heap memory of the computer. It creates objects here. It's instantiate it creates object and creates memory here. So now we are instantiating actually this one, and through this one is arrow operator, we are pointing towards this object, and this object now in return is pointing towards this this acting here, which is a method. So now how the children is going to use this one? The children is going to use, if you guys want the children to, you're going to use this one. There is another concept called abstract classes. So this, if you guys want to make this one abstract class, so I'm going to put it here as abstract class. So what happens with the abstract class is that you guys are going to put a virtual void, and you're going to put an acting here, copy this guy here, put it here, void acting, and remove everything here now. So what happens if we're gonna add some other stuff here, we're gonna add 0 here, so equal to, and put a 0 here. So now this action, this virtual void acting is a pure virtual function. So now any classes comes in and can access this one without any issues. But this one by default, you guys don't need to put anything inside this acting. So now even if you put 100 of child actors, you guys can still can access this one without any issues. All you need to do underneath, you guys need to instantiate this guy here. So that's exactly like that. We're gonna put a parent obj, or you can put a child obj, for example, this guy here. So I'm gonna remove this bit here. I'm going to put a child obj equal to new child obj, child actor. So child actor, and now this child obj here, child obj is going to access acting, which is here in the second one. So hi, I am famous child actor. So here now if you look in here, we have a parent actor, and this is called abstract class. You can put it abstract class. If you put an abstract class, then you guys need to change this one as well, and you guys need to change here as well. So we're going to remove this because we don't want our program to break. So I'm gonna run our program, and we're gonna see if we have any error. So it looks like we don't have any error. Hi, I'm famous child actor. So here, this is called if your class in C++ have a virtual void, and you guys gonna see here equal to 0, it means it's a pure virtual function. So I'm going to put it here, pure virtual function, if it has equal to 0. So if your then this class becomes abstract class. So abstract classes you guys cannot instantiate here, even though we are pointing towards this one, but we are instantiating this guy here, the second one, the child class, the derived class. And here, if you guys looking here, now we have a child object here from this class, and we are using the arrow operator. We are accessing this guy here, but this guy here is getting all the goodness of the parents here from here. So this is the beauty of polymorphism in C++. So as you guys remember, if you guys see here as an abstract class, this is called abstract class now, and this class, through this class we are accessing here we are inheriting this abstract class, child classes, through child class, and child class is sharing exactly the same ones as a parent here. So even doesn't matter even if you guys gonna create the second child character, or the third one, or fourth one, or fifth one, whatever you guys gonna do, if you guys gonna use this one, parent point toward this one, and you guys create an object here, you keep in mind this is just a made up name by us. You guys can put XYZ, you guys can use a new keyword, and you guys can use whatever you guys wanna instantiate here, but instantiate your class. Keep in mind in Java, C#, C++, everywhere is they using the new to instantiate the classes. This concept comes from C++. So now this child object is getting through the member function. So here now we are using the arrow operator, which is very common in other programming languages.